Starting up, starting up, starting up. All right. Let's see. Let's get the YouTube comments popped out. I had to hit reload on it a couple times. It takes a minute for the stream to propagate. Oh no, that was pretty quick. That's muted. Wait for chat to pop up. Pop out chat. Here we go. Okay. We are dual streaming. Oh, this is the same mix that okay, we gotta find a different one. Different mix. New mix. Maybe that one will have a good start. Hey, what's up, Madam? I got your comment. I saw your comment about Oscilloscope Studio. I saw Oscilloscope Music or whatever dropped a new track. I didn't know that's what he used. And it's like his own tool that it's like a really nice comprehensive tool. I don't know if it'll come in handy for us, but I don't know how, engagement, yeah. I don't know how to, I don't know how we're gonna design the visuals on this screen. I need to figure that out. We did AI, and AI gave us a little insight on putting stuff onto screen, although it couldn't do any artwork. I tried to make AI do artwork. I said, make a picture of a corgi on this specific VFD, and it gave me like Arduino code. We're gonna have to figure out plugging the Teensy4 into the screen, getting the right voltage levels, and then we're gonna have to figure out just how to put stuff up, asynchronous serial wise, because I forget all of it. I don't remember anything, but we'll get there when we get there. It'll be cool to see the device actually have some stuff on the screen. I'm probably gonna need a breadboard for this too, and all my breadboards are all occupied. They've got 10,000 things on them already. Do I have just like a piece of breadboard? I might have to decommission my my ladder filter. I think we're gonna have to. Sad to see it go. Love to watch it leave. But yeah, I'm gonna have to take this thing apart. Let's do that right now. Let's work on that. What up, Gonad? How you doing? I'm so tired. I somehow last night I ate a banana, left my pants down here, and got upstairs without using a flashlight. I at night when I go to bed, it's usually like people are only just about to start waking up for work. My sleep habits have been terrible. My sleep hygiene is absolutely ridiculously bad. But I use a flashlight to go upstairs, and I know exactly where all of the creaky floorboards are. So I don't know what I did last night. I did not use the flashlight. But usually I creep up at like 3:30 in the morning. It's terrible. Got up at 2300. Yeah, you're maybe the only person with worse sleep habits than me. I need to get like an early bed tonight. I think I got to do that. I'll have to, because I get bored at night, and then I end up just like vegging out or falling asleep at my desk. So I'm gonna have to creep up a little earlier than I think, and probably sit in bed bolt upright and awake. All right, where does all this stuff go? Where does all this stuff go? These are through-hole things, but I got transistors that have to go back to where they go. Those are buttons. The capacitors, those have got to go home too. Let's get the capacitors off. Some of these are very special parts, so I need to make sure they get back to their homes. 6 p.m. and I'm on my way to bed now. I can see a short distance into the future. Oh, God. I get completely useless when I'm tired like that. I can't think about anything. I can't sleep. I can't act. What's up, Tim? How's it going? All right, which ones are these? 47s? I can't read that with my tired eyes. Use the microscope to read some of this stuff. Whoa, what just happened? What the hell? Hey, SoundCloud, what the fuck? SoundCloud just randomly decided to restart, and it just killed the music. What the? Oh, you know what it was? I think it's because something clicked the mouse. Well, there you go. There's the... Oh, wait, no, we're going to this one. We're starting that track up again. I hit the mouse with this bin right here. Pretty good, pretty good. Good to hear, good to hear. Yeah, we're going to try to work with screens today. Lurked part of your stream yesterday. It was cool seeing you get most of the way with the high side. I think what I need to do, just because of the way the coefficients on the transfer function work, I think one is a divide and the other is a multiply. And so I can use the divide and multiply to change the slope of that line. So I'll have to set this up, probably redo the circuit on the board so that I have a little bit more room to work, and put 2 potentiometers in there, and then I can do the little radio knob tweaking until it matches. SoundCloud certainly doesn't whip Llama's ass. No, it doesn't, and I don't have a collection of music that I can use. I should have been catering a nice playlist, but I gotta talk to the friend of mine. 683, huh? So that's 68N? Is that what that is? Yeah, they're there. I have a friend who has this entire early 2000s trance playlist of all the club tracks and stuff that we used to listen to, and I gotta corner him. I gotta corner him and make him give me that playlist. Give me the music. I'm gonna fucking hurt you. I'll stab you. I heard karaoke starts will be so 2025. What? Milton T. Pike is back after a 20-month break. That's kind of crazy. He's got like 5,000 people watching right now, including Kit Boga and a bunch of other like Djibouti shows there and all that stuff. That's crazy to see. He's got a really nice overlay too. It actually rivals yours, Gonad. He's got his Milton clown jumping on a bouncy house on a TV screen with the TV to the side that has chat on it, and then the overlays make him look like he's a ghost in a security camera. It's crazy. Yeah, I'm not sure if it'll change the slope. There's what's his face in my Discord, Hairbrain. I was talking to in the Discord, and Hairbrain works for the company that makes this chip. But he was actually linking me to some other literature about communism. No, about other literature about the current sensing stuff, and the same circuit had a different transfer function. So I think maybe that transfer function isn't giving us all the information that we need. I think if I modify the 2 resistors, I will be doing a dividing and a multiplying coefficient that will then allow me to do, I hope, do a little bit of the scaling so that we can match the response that this thing expects to see. What a pain in the ass. I would have been done a microcontroller by now if I just started from scratch and did an AT Tiny with a little LED screen on it. But it's like another project, and we're allergic to those. I'm trying to keep those limited, but it's like everything is a yak. I'm surrounded by yaks, chat. I don't fucking know. All right, where are my transistors? They're down here somewhere. Unbelievable. The amount of yak shaving that goes on around here. What is that? Shamal boy? Channel point. I don't know what that is. Who is it? God, I woke up late today. Traumatized my poor puppy by having to go all the way downstairs instead of hanging out with her for a minute. She is very regimented, this dog, and she gets crazy when you don't follow her regiment. She senses that something is wrong and gets all pouty. Here we go, here they are. Yaks are just prehistoric. Hey, what? Well, Madam, you said shamal poi, and I don't know what he's saying. Peel the yak with a lump of C4. If I just take a hammer to everything that I'm looking at right now, I could just stop. I could just go home. I don't have to do this to myself. And yet here I am. This thing is a daunting project. This thing right here, the tester, is a daunting project. I should put like an ESP8266 in this thing and like have people able to put up like channel point messages on it. Like while I'm working, I'm testing something and somebody puts a message up there. What's up, NanoCat? How you doing? Yeah, it's a lot. This is a lot. There's going to be a lot of design that goes into this. Part of a quote from John Lawrence Asbury. That's way too smart. Can we be a little less smart, chat? Deep dives into literature here on my silly little plucky electronics show. Yeah, this mix is pretty good. This is a Deckard of the Space Cowboys. This is my Australian cousin is way into this stuff now because I suggested this music to him. But I use this to fill background noise on Twitch. And it's good stuff. I have a bunch of the mixes in my car. It's just that my car iPod adapter doesn't really work. It doesn't really work all that good. I haven't bothered to fix it. All right, what are these? These are the ones I used as diodes. BC547. BC547, that's this one. So these are 547s. These are the rungs of the ladder of the diode ladder filter. Oh, this is just that one. Hold on. Wait, this is supposed to have other views on it. There we go. I do want to. I want to spend a little bit of time at some point and do my overlays and make my overlays make sense, because I could use some more punchy overlays. Oh, you know what? The ones I just put away might not be 547s. Uh-oh. BC327. Uh-oh. I just put a bunch of the wrong transistor in the wrong spot. Oh well. I guess my transistors are no longer. Pub quizzes. I'm terrible at. Funny thing about O'Bother is that he's absolutely dog shit at pub quizzes. I'm certainly not going to get all the pop trivia, right? Because it's not like I follow. And anyway, the following pop news, like that drama type stuff, is like, it's so confusing. All the stuff that they like. Oh, Blibley's got the skimbo on Bill Hook, and you're like, what are they saying? What are they? What is that? It makes you feel so old. But then they'll ask like deep philosophy questions and like all this. Well, no, they don't do philosophy. It's all trivia. But the trivia is just weird. It's like, where is this coming from? It's all the shit I hated in school. Yeah, we did Quizzo at bars for a little while when I was younger. 337. All the questions are terrible. I hate them. Oop. Was that a 504? 504, so 50 with 4 zeros, so 500K. Goes in there. Chips, go back to where the chips go. Let's go back to here. I think these are all TL072s. Yeah, TL072. 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 All right, easy. Easy peasy. Easy breezy. Cheeky breaky. Oh, that was the wrong bin. Whatever. I'll figure it out later. I'll get mad at myself from the past. Oh man, what a day! What a day! At least we got some progress with the with these guys, with the current sensor stuff. I just need to sit down and redo this circuit and make it a little cleaner, because I think I'll be able to get it to match. I'm not reading. I'm gonna put like a character limit on you guys' comments. What's up, Lawn Dog? How you doing? All right, let's see here. Capacitors. I have a bin full of those. A bin full of caps. You know, having a bin full of caps within arm's reach at all times, just in case somebody like jumps into my shop and goes, "I need a capacitor," is not all that useful, to be honest. Nobody really jumps in and goes, "I'm gonna shoot you if you don't give me a capacitor." And you're like, whoa, 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 whoa. I'm just gonna reach over here. I barely use polar caps in anything. All right, wires, wires, wires. I don't know who decided that in this song, in this chill mix, they would put in a song where 4 people talk at the same time and make a weird sour overtone. It's like creepy, like ghost speak. Why is it in this song? Yeah. Specifically, what formulation do you need in the dielectric? I know you're in a rush and you're holding a gun up to somebody right now, but I need to know specifically what type of cap so that I can properly give it to you. Where's my, I need my bin of through-hole crap that's made it off of the breadboard. That's this one. See, when I get this thing built, I'll be able to test stuff for tones, and that means I'll be able to tune oscillators. And once I can tune oscillators, that means I can bring back the circuits that we were working on for the modular synthesizer stuff. Like, you know, the single VCO and then the chord VCO, we can bring back and get to the bottom of those circuits. That's the thing. It's like this tester is going to solve quite a few problems for me, and I can work without it, but it's going to be good to be able to quickly plug stuff in, get it tested, get it out of here, and get it, you know, done and tested and ready. That's sort of the logic behind what I'm working on. I am not going to ever figure out what these resistors are. They might as well just be thrown out. I'm just throwing them out. I'm throwing out the resistors. I'm not saving them. They're probably a bunch of really useful values, but they gotta go. Nobody's got time for that sort of thing. Nobody's gonna sit down and test these individually. The death of a breadboard project. Sad thing. It's a sad thing. A lot of work went into this thing just to figure out how the filters, how it works and what voltage levels I should be seeing around the components. And it didn't really teach me all that much. It was fun to build, though, and it was cool to be able to build like your own audio filter just out of a bunch of diodes. I like this kind of techno. Good background music. Oh, it's Friday. It's Friday. Nobody's going to 3D print a resistor testing stand. Somebody has and will. You know, listen, time is money, right? My time spent sitting here sifting through what resistors are what and putting them back in the bin when I can buy 1,000 resistors for $10. It's not worth it. That's where all of my little yellow jumpers have gone. Yellow yumpers, little yellow sweaters. So we're going to work with a screen today, which means we're going to be using 5 volts and USB and do a little microcontroller-y stuff. So we're going to get a teensy running on this thing. That means that I can look at some of the tools that are required to design a layout and figure out how that's going to work. It's going to be a lot of work. It's a daunting task. I do not look forward to it, which is why I've been avoiding it, which is why I haven't done it, which is why we're doing it today, because I'm not allowed to avoid stuff. I got to meet it head on in battle. Dope. I can't get that with my big clumsy fingies. Where are my tweezers? They're there. There we go. Board reset. And I'm going to keep my plus minus 12 volt rails like we had before. So I got plus minus 12 and ground, and we'll just get that from over there. We're not going to use the minus, so I just won't hook it up. Instead, we will be doing positive power and ground. And we'll put 12 volts into this board, then I need to make it into 5 volts. The only thing that's going to use 5 volts is the screen, which is unfortunate. I mean, the screen needs a lot of power in order to function. The circuit would be 3 volts, 12 volts for this whole thing if it weren't for the screen. But I want a fancy screen. I don't want one of these shitty looking LCDs on it. I want a fancy 1-bit VFD display that'll look really cool. look really cool. All right, so that's all reset. We're ready to ride. And then this goes to the side for now. Let me make a little bit of room because I can't even use my mouse. There's not enough room. I don't have space. Chat. Way over. Move you way over. Yeah, I'm gonna need to do a lot of op-amp circuit stuff with this thing in order to get all the channels in and out. God, what are all these wires? What's going on? What is all this? It's cruel. Weird. There we go. Nice. I mean, it's not terribly clean, but it is a little cleaner. I can actually get to stuff now. Let's see what I'm doing. Of course, it's all gonna blow up in my face in a minute here when we start working. You take that all the way back there. Put the FAFO sign on top of the wire. We'll at least hold it in place. Okay. Yeah. Yeah. We'll get moving in a minute here. It's kind of warm down here, huh? Getting hot out. I think we're due for a break from the heat, though. I think that's what my weather's doing. Only for it to come back like twice as strong, and then our whole fucking planet just plunges into the sun. I'm pretty much ready for it. I'm so done with summer heat. I'm done. I'm done. Can it please get cold? Can we get the other end of global warming now, where things get super cold and all the idiots say, yeah, but if it's global warming, why is it so cold? As they shovel their car out of 8 feet of snow in June. I'm ready for that end of global warming. I've already had my chat convince me that lead is totally fine and I should be drinking it. You heard it. Apparently my chat says that lead is healthy and it's part of a balanced diet. You know, like that breakfast that they show on TV that's like orange juice and 6 slices of toast and a Pop-Tart and like 5 bagels. You're supposed to eat all of that for breakfast. Balanced. And a bowl of sugary cereal. Balanced. Apparently a block of lead should be added to that too. For some fucking reason you guys are convinced that lead is perfectly safe. How else did you sweeten your cereal? Yeah, there's a bowl of sugar that you're supposed to put on your sugar cereal that's made now with 100% more marshmallows. I don't eat breakfast. I don't wake up early enough to eat breakfast. I don't do demanding enough tasks to need breakfast. Where have all my Phillips heads gone? Why am I looking at a whole bunch of flatheads? This is like all flatheads. I have 3 Phillips head and 4 flatheads. 1, 2, 3, 4, and then 1, 2, 3. There might be a rogue screwdriver somewhere. I don't think they give you an uneven number of screwdrivers. There must be a rogue screwdriver. I don't know where it would be. I'm looking around. Made it onto another bench? That's probably where. I'll have to keep an eye out. I'm going to get the modern 3D printed parts on this thing. We're almost there with these. I think what I need to do is rebuild that circuit and then play with the 2 resistors, because I don't think that transfer function is exactly the picture of what's going on. I think that's a simplified transfer function, because I found a circuit that has a similar design, and they actually have one value is the multiplier and another value is the divider. And I think using those two, I don't have an offset, but I do have well, I would have an offset if I put in a resistor on pin 2, maybe? But the point is that this transfer function isn't exactly what's going on. So I think if I noodle around with R2 and R1, I can get it to match hopefully accurately. Hopefully, I mean, it's not accurate in the nanovolts, but I don't need that. That's not what we're doing. These displays are very rudimentary. Very rudimentary displays, all I need to know. And basically, the display is just there to give a pass-fail about current consumption. You know, if it's on hundreds of milliamps, everything is fine. If it's on amps, it's dead. Hamster overdrive. Hiya, brother. How are you today? I just am. That's all I can really. Can I ask about your thermal camera? No. Yeah, you can. How's it going? Hey, Brink. Let's see. What was the rest of the comment? It'd be nice to know why you did your own and if it's better. So my requirements are different for thermal cameras, right? I'm not moving around with this thing. If you're doing engineering with like a thermal camera, like absolutely it should be a portable device because it gives you so much of a better picture of what's going on. Especially in electronics, where if you power something up and something heats up. Like I've had times where I haven't been able to notice it, but my power supply wires got hot and suddenly they are glowing in the thermal image. But for me, because I'm doing a show, I am chained to the desk. I'm literally, you guys don't see it, but there's actually a shackle around my leg and it attaches to one of the legs of the desk. I'm not allowed to leave. So the thermal camera stays here and I need a frame rate that supports streaming. So if I wave my hands around to gesticulate about stuff, because I like my gesticles, you guys can see it in a high frame rate. So what I needed was something that would hook up like a webcam. And so GroupGets has a thermal webcam module. Happens to be really, really tiny. And then the Lepton thermal imager is affordable. It was like $150. You can get them for much less now. So I put 2 and 2 together and then discovered that as I'm streaming and I have this thing up against the webcam, I'm bumping into it and bumping the camera out of the really terrible Molex socket. Because you're supposed to solder it down. You're supposed to solder it down and there's like componentry and stuff on it. It's a really advanced little thing, the thermal imager core. You can get a 3D model of that thermal imager core and you can get a 3D model of the GroupGets circuit board. And so I put those together and I have a comprehensive 3D model that includes the viewing area. It has a body on it that does the viewing area. So you can literally just put a square around it and say extrude using this and it'll remove all the stuff that's in the side of the webcam. Brilliant, really brilliant stuff. So I was able to make this enclosure and I discovered that this webcam, the thermal imager needs air. It gets hot. It gets hot. It needs cooling. Otherwise, your image becomes terrible because all the residual heat bleeding into the imager. But yeah, once you catered all that stuff, I now have a little armored webcam here that I can knock around. I probably should have put a switch on it so that I can turn it off between streams because this thing has been like on. The number of on hours that this thing has clocked is probably a year deep by now. But yeah, anyway, that's basically the story of the webcam. It's just I've broken one of these just from having it fall out. So I had to make a 3D printed enclosure and it's been rock solid since. The Lepton imager also has a little door that shuts over it so that it can calibrate itself. It's just stuff you need to cater to. Other than that, I mean, yeah, the technology, the thermal technology has gone a long way since we did this project years and years ago. So if I were to do this again, I would probably be looking at the units that are being made overseas. Like China has caught up with thermal cameras, and there are some units that offer frame rates and resolutions that blow away anything in the US. Anything in the US, like we have an amazing amount of technology in terms of thermal imaging, but that gave us an edge on the battlefield, and so it became ITAR restricted, and so we only get like 60 FPS and stuff. It's just the same reason that GPS can't go a certain speed. GPS will shut down if you go too fast with it, because that can be defense technology. So, so we get shitty thermal imagers that are really, really expensive instead. It's what it's. Munitions like PGP, I don't even know what that is. I don't know what that is. Yeah, I love to talk about the webcam. Not a lot of creators do anything with thermals. As far as I know, then again, I also keep myself sequestered away from other creators so I don't end up getting ideas from them. Because I'm too susceptible to that. I'll start using their memes thinking I'm clever. But yeah, some of those Chinese, maybe not just Chinese, I think there are other peeps are making them too, but they're making these awesome thermal imagers. Awesome. Awesome. This circuit board stack is going to be something else. I don't even think I know what I'm getting into with this. It's going to be tall. Ooh, I love it when songs do that. Doop doop doobie doo. I need a drum machine. I should get a drum machine. Or like a shitty drum machine. Now, I can't buy anything. I gotta make stuff now. I have to actually use the stuff that I've bought already. Justify more purchases. That's life, isn't it? You know, you just keep buying stuff until you die. That's my sunny outlook on life. You're well on your way to making one. I know. I have all the 7400 series chips that I could make one out of. There was that 7400 series Logic drum machine, drum sequencer. That's always looking tempting. That's a tempting project. Looks like I need to remove more than just that in order to fit this in. Ah, come on. So this has to be offset a little bit. Like it needs to be in the middle. This should go all the way to the corner. I guess I can reverse this one. I can flip that one around. I can flip it over. Over. Just trying to pack things up a little bit here so we have room to work. Because I really want to get to this screen. I really want to check out this screen. I think it'll be pretty snappy. If I do the 7400 series drum machine, I'm going to need buttons with LEDs on them. The little key press buttons, the kind that I used on Burn the Subs. But I only had 2 of those. I'm going to need a bunch of them. More than 7. And then I will need to... what am I going to need to? Figure out how we're going to do that. If it's going to be on perforated prototyping or if it's going to be on... It probably should be on perforated prototyping board, to be fair. I don't think making a PCB for somebody else's design is too justified. Plus, we can think on our toes if we use perforated, and I have, like, improvements that I want to make. That's a project for another day. I'm not going to start on that one all of a sudden. We need to get some projects cleared before we start new ones. That's the reality of it. Yeah. How am I doing this? Do. Lines up close enough. All right, now I have room over here, and I can put this back in. This is so much project. Just this one thing that I'm trying to build. It might have been a better idea to build something that just simply makes the signals that I need and doesn't really do much else. But this is something that will benefit me in the future in terms of not having to spend months fixing things. I think anyway. I hope that's enough justification for you guys, because it sure is. I sure took a big bite out of this one, huh? That was a bit too much of a bite for me. And we got to get back to Burn the Subs. Everybody's asking about Burn the Subs. They're always talking to me. They say, Sir, you're so beautiful. You know, you're so great, and I love you. And I'm just wondering when you're gonna get back to burn the subs, because you're so amazing, and you've got big hands. People are talking. You know, people. They come to me. They say, "Screw on here." Oh, come on. Go on the thing. Oh, you little bastard. There's room for it to turn. It's just not hitting the threads properly. There, I think I got it. Yeah, there we go. So if I butt this all the way up against here, then I can have I/O either coming out this end or this end. I think I want it here, because here I can make a panel that'll fit in here, and it'll stick in properly and hold everything up. No, the voices never have good ideas. And most of the voices are external to my head. They're in chat. All the chat voices. I don't need to have a runaway inner monologue. I have a runaway outer monologue. Yeah, that's the thing. Sometimes you do have to spend your way out of a problem, and I'm well aware of that, and the fact that if I were to just buy a module testing module, I would be out $300, but it would also solve this problem that I'm having with not having the ability to test modules. That certainly does hold truth. That holds water. And truth. Truth water. Oh, I need to make truth water. Oh, I could be a billionaire. Well, maybe not a billionaire. I could make millions off of grifting idiots by making truth water. Buy an M303. I'm about to get sent another M303 once I'm done negotiating about fixing one. I'm about to get sent another broken one. I need to find, I think it was, I forget who had that link, but somebody had that link. I want to say it was Ben Gizmo, because Ben Gizmo has weird knowledge about all this stuff. However, I don't know if that was Ben Gizmo or not, but somebody has that link for what Acid Labs does in order to fix these things. And I need that again, because we've got one that may potentially be sent in from overseas that that had the same exact whoopsie poopsie doodle error and blew up. Truth water, bubble pure facts through it. Yes. Yes. Ooh, this one's not tightening. Why is that not tightening properly? Property? There we go. Gotta find the threads that have been sort of imbued into the plastic. This could probably do with some repositioning. Yeah, that one too. Oh, but I can't really get to it. How far off is that screw hole? I can see through it. I can just sneak this down just a touch. I can't get to the bolts. Maybe I can just hit it with the pliers. Yeah, maybe I need pliers actually for this, because there's not a lot of room to maneuver. I actually can't get to it. Ow. Scratching myself on the through-hole port. There we go. Now we get this thing in. Yeah, these panhead screws are my favorite to use with 3D printing. They're a little bit moody though. If you're not careful and your holes are too tight, this thing can destroy them. It'll basically roundinate your Phillips heads. There we go. That's looking a little bit more fleshed out with those panels in place. And I'll have a side panel over here. The rest of it's going to be open air though. It'll just be open air because it is a test stand. It's not supposed to be enclosed in any way. And the reason that I have the panel there is so that I can hold things like the power switch and the MIDI jack that are not board mounted. They're not board mounted. So the big old power switch over here. and a big old connector for the barrel plug that'll go directly to the PCB. That'll be cool. That's gonna be cool. We could have worked on that today. That would have been more fun. No, we can't have fun. Fun is anathema. Fun is disallowed in this space. We must work. We must do work. All right, I'm gonna coil up these and get them out of the way. Maybe all of them, actually. Get all of them out of the way. We'll come back later. Let's keep the leads with that one. Grab that. Make the desk sparkle. Make it look nice in here for once. Make it look nice. Like an accident. Be nice if that frequency generator had a place to be. We're gonna have 2 channels that are able, well actually 6 channels that are able to independently make signals that will excite modular synthesizer stuff. So it's gonna be way more powerful than the scope setup that I have right now with my singular frequency generator. That'll be nice. Let's put these behind with all the other mess. And then the scope probes actually do have a space in this drawer cabinet. You gotta really, like, especially if you're 6 times the excitement, 6 times the fun. If you're working with a bunch of engineers and you have a singular lab space, I cannot tell you the value of these scope hats. Scope accessories are extraordinarily important to keep track of, which is why, even in my singularly owned shop, I have a special place for scope stuff. So all my scope stuff is in this drawer, and it does not go anywhere else. It doesn't stay out, it goes back, and it goes back into this drawer and nowhere else. And if you take the hats off of your scope, you put them in here or you keep them next to the probe, because I cannot tell you how freaking annoying it is to not have a scope hat when you just want to hook into a signal. My probes are the red ones. I know, I should have bought my own set. I should have just bought my own set and used those. Because they're not expensive. You can buy these things for cheap. These the BNC scope probes, they've kind of standardized the features on them over the years of electrical testing tools. There's some variation, like when you get just like a crazy manufacturer, but like from Tektronix to Rigol, you're looking at just about the same thing. So you can buy generic ones that work just the same. I feel like I am missing a screwdriver. Maybe not. Truth water, we bubble burned tomes of knowledge through it to capture the essence of truth and abuse. That's like a magic potion. We're not talking about a magic potion. I'm gonna sell bottled water, or maybe like a LaCroix knockoff that's called truth serum. No, truth water. I don't fucking know. The idea doesn't sound as good anymore. It doesn't sound as good anymore. I don't think it lasted the perception of the I don't know, the public scrutiny. After sitting on the title for a little while, it lost all of its power. Oh, look at how neat that looks. Neat and clean. Oh man, that makes my dingle tingle. What am I running into here? What's going on? I think it's the pins sticking down through this board. Oh, that's right, that's what it is. The pins are sticking down through the boards. Oh, we're gonna need this today. There it is. That's our buddy right there. We're gonna need this, and we're gonna need this, which is the 5-volt Pololu power supply. It's all Kickstarter stories right now. I haven't checked in on Kickstarter in a while. We had that one chatter just come in and like advertise their Kickstarter, which I didn't. I should push back against that kind of stuff a little bit more. It's like if I know people through chat, like if Tim 19862 suddenly came in and said, "Here's my Kickstarter," I would be like, "Oh, cool, yeah, check out Tim's Kickstarter." But I had a chatter for the first time say one message, and then the next thing was a link to a Kickstarter that was sort of in this space, but it was also not a good look. And I need to push back against that stuff a little harder. It's like, I don't care, but it's not related to me, and it's not my thing, it's theirs. So, and they're probably never going to come back. So it's like, why am I humoring this? I was a little bit rattled yesterday at chat. For some reason, saying that lead is fine. It rattled me a little bit. It's possibly the dumbest thing that I've ever had to argue in my entire life. It's up there. It's up there. This is also here to solve arguments. Yeah. How do you trust somebody's mental state when they tell you lead is fine, when lead greatly affects your mental state? Yeah, of course you're arguing that. Oh, I wish I'd come up with that at the time. That's a good one. You see that logo right there? See that logo? See that logo? You guys see that? You see that logo? You see that? Look at what this is. It's a turn signal. It's a turn signal for a BMW. I mean, that probably means that a BMW somewhere is missing its turn signal, so maybe that's not such a good argument on my end. Maybe this isn't so much of a good argument. It's the clicker-clacker lever. It's kind of cool, though, because it's got this little plastic piece where when you tingle its dingle, you dwindle its dingle, it resets. So if I turn the wheel this way, this thing is going to move that, like that, and then if it goes the other way, it'll disengage. Pretty cool. Look, there's a whole art to having a chat and reading the messages. I can't ignore everybody, unfortunately, because my chat just doesn't move. Nobody talks. It's nice when people do start talking and the chat moves a little bit. There's a whole thing about engagement and getting people to talk in your streams. And I see other creators who I could name names, but they'll suddenly start talking like some dog shit political opinion just to get chat moving. It's crazy. You can tell when the bait has gone out and when people are catching it. So I do ignore comments every now and then, but it's like I can't stop myself 100% and address some things people are saying. But for the most part, it's super obvious when I do that because my chat just doesn't move. What's the vestigial stock not used by many BMW drivers? I know the second part of this not being such a great argument is that it's so clean. It's like it was never used. It's like it's brand new. It looks brand new. It came from a car that probably got into an accident for ignoring the function of this lever. Really cool little piece of mechanics there on that reset thing. I like keeping that within reach, though, so I can say they do exist. It's now BMW for long road trips only. That's why I don't signal on the highway. You're not supposed to use turn signals on the highway, right? I love that kind of drum progression. That's... Hold on a minute. Isn't that supposed to be in your car? No comment. Actually, mine's a generation older than this one. Although it's pretty much the same thing. I think they've used the same turn signals throughout all the modern BMWs. Thought you had a Volvo. No, my family is very Volvo oriented, but no, I have a BMW station wagon because all my friends drive BMWs. They're big BMW nerds for like modifying them and stuff. And so if you've got hyper nerds with a particular car company, you buy that same type of car and then you're in. You've got the service. You know, we all know what we're doing when we work on each other's cars. Is that a euphemism? It's not a euphemism. It's not a euphemism. You know, you kiss your homies goodnight, and then you help them work on their cars. That's just the way of things. Yeah, we've done, I uploaded it to the VODs, but I've got the comprehensive streams where I'm noodling around with the ABS computer unit, and it's just a total shit show. I eventually bought a completely new one. Except you have the station wagon 330i. I have the station wagon 528. It's a 5 Series. It can get out of its own way pretty well. Although I do like the 3 Series better, and I wish I had an E36 station wagon, because those look awesome. The E30, not the E39 that I have has the jelly bean look. The jelly bean look of the 90s, where everything got fat. Everything had a few too many, and it's just bloated. That was aerodynamics, and it totally ruined all of the square styling of the 80s. And then we had sort of a backtrack of that during the 2000s, where everybody said, hey, what if we put lines on our cars? And so, you know, we're recovering from that, but the jelly bean era is something that I really dislike. Mine is a jelly bean era, unfortunately, car. The previous version of that car was just beautiful, beautiful design and styling to it, and I wish I had one. If I come into a lot of money, I won't tell anybody, but there will be signs. I will have a nice-looking station wagon. Station wagon is a cheat code. It is a cheat code. I do not like to drive slowly. I get bored. I drive like my hair is on fire. I dial it back for people, and especially in a movable couch, I've calmed down a little bit. But the station wagon is a cheat code. Police do not see you. I have sped by police in the station wagon before, and they do nothing. That or they were bored at that time or something, but it's generally they don't, they're like, that's a station wagon, they're not doing anything. And I'm sitting there with like 10,000 bees in the car that I'm smuggling to like, smuggling over the Mexican border, and they just don't see it. So a lot of bee smuggling. What color? Something neutral? What, are you going to steal my car? Is that what we're coming to? You're going to jump down on Google Maps and you're going to go around looking for exactly my model of car, and you're going to find it, and then you're going to fucking rob me. I know what you're on to, Tim. It's blue. Why would I pull over a pregnant mother? That lady's just trying to get her kids to school. They just see my flowing locks of hair. That bearded lady is just trying to get her kids to school, I can tell. Just trying to get the dogs to the park. Yeah, it's not gray. A lot of my cars have been gray in the past. Actually, they've been blue and red. The BMW was my first gray car. The 330i that I used to have. That was my first gray car. Which is, I mean, that's a neutral color and everything, but it's like, get something weird. Get a weird color for your car. Like, why not? What's the, you know? Get a strange colored car. I had the most, like, white bread milquetoast car in the world. It was a 330i that was gray. It might as well be beige, like, at that point. I can't, no, white and black cars, I don't like them so much. I don't like the, I don't know, it's too bleh. I want a yellow car. I want something in yellow. Yellow or green. Nobody likes green. I like green. You don't exactly have a ton of colors to choose from with cars. I mean, it's like, nobody's really out there driving an orange car. Yeah, the neutral, non-metallic colors are very easy to get dirty. They get dirty. Pearlescent Mustang SUV. All the cars in this neighborhood are white. I've noticed this. During my walks, there are a lot of retirees around here, and just around 10 o'clock, 10:30 actually, 10:30 in the morning is when everybody has that existential retirement dread, and they decide to get in their little crossover cars and go out to Starbucks to clog up the roads for younger people. And that's 10:30 is when all of the white SUVs pull out of the driveway and start buzzing by me and my dog, who for some reason thinks that every car has a treat in it, because people will wave and they'll stop, and some of the neighbors and friends will, especially the mail lady, will give Willow a bone. So if I ever lose Willow, she doesn't run away. She doesn't go far from us when she runs. But if she ever decided to just book it somewhere, I would go to the post office, because she goes right up to mail trucks. The problem is, like, she really just wants to jump out in front of a car. And I can't train her not to when people stop and are all friendly and go, oh, hey, cute, it's Willow, hi. And she's like, oh, hey, people, cool, let me run up to cars. Like, dog, you are a very small dog. You need to look out for big cars. and especially old people behind the wheels of big cars who have heavy feet in this neighborhood. It's like a small neighborhood here, so it's kind of a nice spot to walk a dog. But yeah, it's not a fun problem. It's very difficult for me to train away that behavior. Try to get her to go on grass when a car goes by. It's difficult. I don't know how I'm going to be able to do it. I don't know if I'm going to be able to do it. Anyway, let's get to doing stuff. It's been about an hour since I started up, so let me start soon out of here. Let me get the music out of here. This is just Space Cowboys Deckard mix. This is one that we've listened to a couple times before, but I actually kind of like it. It's nice. It's a nice somber mood, and it's a little poppy. It's got a little stuff going on. Anyway, it's the music that I look for to fill the background of my stream. Hi, it's Obother here, and he's tired. Oh my God, what's new? Yeah, I didn't get to sleep until really late last night, so I'm kind of dragging a little bit, but I think we can get some progress done on this project. As far as the current monitors that I got set up yesterday, we got this to work. I think this circuit is going to work out. I need to add another potentiometer to it so that I could potentially scale and stretch that that voltage swing from the resistor. I think that's what I need to do. I'm not sure if changing the load resistor is going to do it, but I think if I'm testing lower wattages, I can use my generic resistors as a load resistor. I just need to measure them. Actually, no, I can't because they don't go low enough. I don't have a 0.2 ohm resistor. So I'm stuck with this one. I'm stuck with this RL and scaling that to look like it was a low side. I don't know why there's that difference though. Why is there that difference? Anyway, I think what's going on is that the that transfer function 5 1 ohms in parallel. But then with if I did that, yes, that is viable, but at the same time, these freaking little guys here, these stupid 1% resistors, like, more getting angry at the 1% now. Bother's just ranting about the 1% again. These stupid little guys, okay, you know, they don't even like to be on camera. These stupid little guys have such small leads that the clips inside of these breadboards don't necessarily give you good contact. So if I were to make an RL out of some of these, I would either have to solder it or wiggle it until it works. So I don't know. I mean, that's a possibility. I do have 1 ohm resistors that I could use for that. I'm starting to make a use case for one of those resistor decade boxes. I should probably build one of those. I need a lot of switches to do that though. Actually, I bought a bunch of switches. I have toggle switches. The ones that we had in college had just little, you know, on off, like the little push switches, the linear ones. Yeah, PCB decade resistor jobby. I have to find terminals too, banana plug terminals. I think I have a bunch. I think I have a bunch somewhere. I need to find them. I don't know where they are. They're around, but basically just take a little box and put a bunch of resistors on it on switches. That would be kind of a useful thing, wouldn't it? Although we have potentiometers. I could just get by with potentiometers. Was only a $5. Yeah, I mean, maybe I need to buy something like that. I can 3D print it, though. I was given an old resistor box with 2 rotary switches. Engineers will turn any kind of a unique switch into a resistor decade box. I think it's a law of physics. I've used it once. I do a little bit more test and measure around here. I don't know. Maybe I'd use it multiple times. Maybe not. When have I ever needed that? You're probably right. You're probably right. If you guys haven't noticed, I took apart my penis ladder filter. That's a strange thing to say. It's a diode ladder filter, but if you look up the circuit, it's penis. It's a penis. It really is. I took apart that filter because it was just supposed to build. I was just supposed to build this because I wanted to see what the voltage levels swimming around on the schematic design would be, so that we could fix the 303. So I built this, I got it working, and then I had Julian plug it into his synthesizer, and it didn't blow up his synthesizer. It made a nice little cutoff filter that he then immediately didn't use and told me that I needed to go do something else. Fuck you, Julian, piece of shit. Anyway, he had all his gear here, and I had him plug this into the rest of it. And it was really cool for me. He was not too jazzed about it. He was more nervous about having plugged it into my stuff. So... it's the way it goes. I spend the sweat of my brow, the blood in my body towards building him this amazing thing, and he brushes it off. Anyway, so I've cleared that off. We're done with it. I don't need it anymore. I had it for sentimental sake. What we now need to do is work with this screen, and I wanted to do some stuff with VFD displays because we have a really cool VFD display in this project. What we have is one of these Noritake e-tron VFD character and like image display. It does like images on the thing using serial. I need to figure out how I'm plugging this thing into the rest of my stuff, and I need to get it actually churning away, doing things. So in order to do that, we need a microcontroller, and we'll just use the microcontroller that the rest of the project is going to use. And that is right here, not here. Where is it? Where did the microcontroller go? Where's the one with the legs sticking out of it? I have one that I haven't soldered sitting over here, but where'd the actual microcontroller that we were going to use go? Is it in the bin? Uh-oh. This thing keeps falling off of the magnet hanger. I'm just going to put it over here with the other weird 3D printed stuff. I should spool up with model painting and do a whole model painting stream. We should do that. I should print out a bunch of miniatures and then do a model painting stream, but I don't know what the hell I'm doing because I've never done model painting before. In the 90s, I did a little bit of model building, you know, those kits you buy, but I have never really done the painting of them. I always loved that for like TV shows and stuff when they do the kit bash stuff for like miniatures and actual like special effects like that. I'm always jealous of the people who get jobs doing that stuff. That seems like it would be awesome. Yeah, here it is. This is the TNC4 with legs. And these are proper square legs, so they go into the breadboard really well. So we're going to get this thing pumping away on our stuff. Okay, so we're going to have a 5-volt regulator on this. This thing can take 5 volts, but it works at 3 volts. So, I mean, technically, I should probably put it on a regulator, but I think I can feed it. I think I can feed it from the 5 volts. We'll put it over here. Oh, geez, that's new. Okay, let's figure this out. All right, so that fits a little easier. Those holes are better. So, and then we can have our level shifter over here. Now we need a level shifter because this thing talks 5 volts, this thing talks 3 volts. And unfortunately, due to the choice of processor in the TNC4, Paul Stoffrigan, whose fault this is, switching over to the TNC4 because of supply issues on the TNC3 chip, this one unfortunately is not 5-volt compatible. TNC3 is, but we're using the TNC4 because of the audio tools that it has. It's got some amazing audio tools. It's just different architecture that can kind of leave you high and dry. Once every 3 years. I've been doing this for tens of years, and I've never, excuse me, I've never been able to get through a sentence without burping. I've never needed one. I've never needed a decade box. Okay, so we're not talking about this thing. We're actually over here with our main processor, the TNC4. Now, I've been keeping an eye on my ins and outs because we're going to fast run out of pins on this thing. We've got a display, we've got an audio bus, and we have just all kinds of stuff going on. So I need to keep away from the pins that are used for other stuff. And I have all these analogs circled, but still. So, what I am doing, well, I've got RX1 and TX1 sort of hobbed out, and then VIN 3.6 to 5.5 volts. So that's where we'll feed our microcontroller from with 5 volts. Our outputs are going to be 3 volts, so we need to send this 3.3 volts to the voltage level shifter. So let's get a picture of the voltage level shifter over here so that we can kind of put that down on our worksheet here. This is what I do with these projects is I keep a worksheet going, and the worksheet might get really, really crazy and sloppy, but it ends up becoming a sort of a living document, a working document for what I've done. Otherwise, I don't have any of this data, and I'm high and dry when it comes to testing things out and fixing things when they break. So yeah, that's not in there, so we're deleting it, and then this is going to get a box around it. And I'll put nice big meaty lines. current mon. Here and I. Okay, there's current mon. And then this is the rest of the circuit. So we've got to be wary of our pinouts, because I'm gonna need pins that go to the different switches on these things. It's gonna be just a lot. It's gonna be a lot. So we come down here and I need to do the screen stuff. That's this right here. The GU700. Cut that and let's put that over here. And I'll move MIDI into the corner. And then we have room to work. Okay, so that's the GU700 screen, 7000 screen. We know what the pinout is. It is asynchronous serial, although I have actually got it. I think I have the jumpers set up for synchronous serial. So that's VCC, serial in, grounds, bussy, serial clock, and reset. Those are the pins that we're going to need to actually send to the microcontroller. And so we'll have to figure that out in a minute. Before we do that, I need to actually take a look at what this is, my level shifter, so that I know I'm using it properly. Where's that? There. I hate having to use these things, but I guess we're just kind of stuck. 6AK, or is it AYR9, or is it YF0BE? Let's try YF0BE datasheet. YF0BE. Actually, it looks like we got the right thing. 8-bit bidirectional level shifting voltage thing. Voltage translator for open drain and push-pull applications. I don't know if this is going to be strictly necessary. I wonder if I could just use a bunch of... I could either use like an optical isolator or maybe something similar to that. I don't need 8 channels of data shifting, unfortunately. I just feel like I'm overutilizing something. So VCCA, and then you have A1, B1, etc., and VCCB. So AB, OE, I guess, is maybe an enable, an iso-optilator. I wonder how that person's doing, the person who changed their Twitch account to iso-optilator. Hope they're doing okay out there. 1.4, 3.6, 1.6, 5.5. So we have to use channel B, it has to be the 5.5. Yeah, VCCA, A has to be less than B. I think that's all she wrote. I just do channel A, B, and C or whatever over to the microcontroller. And that way we keep from blowing things up. Okay, so that's easy enough. Let's take a look at what we're doing here. So VB is going to be 5 volts, VA is going to be 3 volts. So we can send 3 volts from over here, just from this pin right there. And then we'll send 5 volts over to here from that pin right there. Where are my tweezers? There's a hair on the microcontroller. It's driving me nuts. Get out of here, hair. It's like an eyelash. Whose eyelash? Okay, so 3 volts here going to VA. Easy enough. Let's get this hooked up. And then I'll make 5 volts over here. These leads are not very good. They barely stick in. Well, it's going to have to do. All right, so VCC to VCC. Oh yeah, let's sort out all of our grounds before we do anything else. Everybody connected to ground. So I've got positive 12 ground, ground, negative positive, ground, ground, negative. It's kind of a little maddening here, but it gives you those plus minus voltages and plenty of grounds. And I labeled it. So everybody gets grounds right now. I don't know what OE... OE has a resistor on it to ground, I believe. But yeah, ground over here on this one. Make sure that is actually a ground. Yeah, it is. I'm not really going to be using the rails because we're not doing op amps. We're doing digital stuff. This is a lot of channels, too. It's a lot of channels for not all that much, especially given that the serial communication is asynchronous. All it does to communicate back is say, I have something going on this line, or I'm busy right now. That's all it's able to tell the microcontroller. That's all we needed to tell the microcontroller, but maybe I'll just set it up with a couple either opto isolators or just a transistor level shifter. Anyway, I've got this thing, so I might as well use it for this. So there's our hookup to 3 volts from the 5-volt regulator on that thing. And then I need, or sorry, from the 3-volt regulator, I need this power. I don't know if I want to do it here or if I want to move it somewhere else. It doesn't really matter. It could be far away if it needs to be. Let's just put it up here. Let's put it all the way over here. No, that's going to be way too long. No. Well, we also need the 5 volts here for powering the screen. So, because I'm gonna put 12 volts into this, just like we're in the final system. So yeah, let's just park that right there and let's get its ground hooked up. The ground. This is popping out way too easily. I guess we'll just have to be careful, because if I touch this wrong, see there, it just popped out, and it just floats. Terrible. So V out is going to be a long connection. Oh, and we need power into this thing. So power coming from 12 volts. Let's see here. Plus 12. That's power good. V in. There we go. They generally, Pololu makes these to be compatible with like your 7805s. You can just take the 7805 out and plop this thing in and have 2 little floating pins for your pleasure. That maybe needs to be a little longer. Well, we'll deal with that later. Okay, so let's see. Ground, we got that. We got VB. What do we do with the OE pin? The OE pin. B5, tri-state output mode enable. Pull OE low to place all outputs in 3-state mode, reference to VCCA. No, so we're not doing anything with the OE. We're not doing tri-states. I guess positive, negative, or plus 0 and float, maybe? I don't know what that 3rd state is. Yeah, this thing might actually be kind of useless, to be honest. All right, well, we're using it anyway. Bonk. So what else do we need to do? We need to hook up the microcontroller to power and ground. So let's get ground on this thing. Ground is going to be a reach down here, so we'll use green. Yumper. It is a shame that this platform dropped its 5-volt compatibility. It makes this design a whole lot more annoying. I mean, the capabilities of this microcontroller are insane. Unfortunately, it's got a little lock stamp on it because it's locked. But yeah, the capabilities of this thing are crazy, but it does not allow you to use 5-volt signals. It'll explode, and I'll be out a very expensive microcontroller. Now, how do I do this without blocking? Because a V-out's way over here, and it's all the way on the opposite side of what I'm powering. I guess what I'm going to do is do a really long wire and just walk around the park on the outside here until I get over to 5 volts. So I'm going to need an expressly long piece of wire, which we have, because these kits have an even number of every length, which makes them very annoying. I don't need an even number of every length. I need more skewed towards the middle lengths than anything else. I think it's bootloader locked. I'm not sure what the programmability is on these, because it is a proprietary thing, right? Actually, we should jump over to this, and then I can jump over to here. That'll make it a little cleaner. So VB here is 5 volts. But I need to keep this area clear, so I need to go out and around. So we need a little bit longer than this. Maybe a blue, maybe a green, a big green, maybe a blue. Yeah, it's not like, you know, the Arduino cores where it's just like totally available and you can just get whatever core. That's too long. You can buy from Paul Stock. You can buy from PJRC a bootloadered chip, I think, from him. and then use that in your design if you feel compelled. Although, you know, I'd rather use something a little bit more open than that. Because like people argue in chat, and I've, you know, I totally agree with them, is that if one person can tank an entire like branch of this technology that they've made, it's not good. In the same way that he tanked the Teensy 3s, he had good reason to, but it still means that your project could get the rug pulled from under them. You know, in your SOL in terms of what your ecosystem is going to be. All right, so we have not done the 5 volt yet. We need to get from VB. We can do a little jumpity jump from VB over to our micro, which would probably be another green wire. Once we set up all this stuff, we will start working with the screen, and I'll start getting my ducks in a row. I don't know what I'm doing when it comes to programming for the screen, so we're going to have to get introduced to that sort of thing. Ooh, perfect. This is perfect. It's perfect. It's blurst. Look at that bussy. I mean, what? Yo. Bussin'. Spussin'. S-bus. Okay. 5 volts. We got our 3 volt out going to our VA. VB is getting our 5 volts from our 5 volt regulator. Our 5 volt regulator is getting power from plus minus 12 volts. Although we don't need minus 12, 0 and 12 volts. I'm doing this just so that this is similar to the final design. I want to see how this thing performs in this sort of environment. And then maybe we could do different voltage level shifting, because this is a lot of ins and outs, but this lets us hit the ground running. We get to shift our voltage levels immediately and then live with our, you know, what we're doing. So what are we going to need for the screen? GU 140 by 32 7000 and 3D is not the model that I have. The screen I bought is a 7000 series, which has almost no support for it. We have the datasheet for a similar one that has more capabilities. So I have a feeling that I got these for like $60 on eBay, these $120 screens I got for 60 bucks on eBay. And I have a feeling I did that, I achieved that, I accomplished that goal in the wake of the fact that there's very little support for these specific screens. This specific screen only does asynchronous serial, whereas its contemporary, the other models, the ones that I can find datasheets for, can do I2C and stuff. To be able to actually work with the technology that I have. I have a feeling that I got a cut rate discount because these things are annoying. But you know, this microcontroller should be capable of doing that serial stuff. We just need to find the right thing. I need to make some scenes. I gotta do that someday. Is reinvent all of my stream look so that it's a little bit less rigid and we have some like cool scenes. One day I'll get to that. One day. VFD tubes are made of glass. High voltage. Specified voltages, because some VFD modules may consume in rush current more than typical, blah, blah, blah. When discarding VFD modules, take a hammer to them like Gonad did. Governmental related laws or regulations. VFD modules designed to be protected from electrical noise. Please plan your circuitry. Blah, blah, blah. Okay, how do I do thing? Those are the specs. We've been over this data sheet before, so we know some of the stuff that's going on. The following interfaces are available for this module. Serial interface, CMOS synchronous, asynchronous, SPI or I2C selectable. That's not the case, and that's why I have this data sheet up. This data sheet is for a much longer screen. It's actually kind of cool. It's probably like $200 too. But this thing is a slightly different screen, but it has the same setups. Spussy. It has the same setup. It has the same data input. There are 2 serial interfaces, CMOS synchronous or asynchronous. They're selectable by a jumper. The module sets the SBUSY line upon receipt of data and clears the line when ready to receive more data. So I think we need to do the SBUSY sign, and whether, like, should we do asynchronous or synchronous? We'll need to find like a hello world. Hidden area can also be displayed using display action command group. There's, I guess, a hidden area of screen memory, huh? Window functions, base window, user window, right screen mode for base window. The problem is the Arduino libraries that we found for these screens, they use interrupts in order to stop things from moving on the, or not to stop things from moving, interrupts in order to do the serial timing, which is bad. We do not want to use any not interrupts, wait functions. It uses wait functions which tie up your thread and stop your microcontroller from doing stuff. We can't do that because we're streaming I2S to the audio stuff. Okay, they get into the nitty-gritty pretty quickly here in terms of serial. I was looking at what the hookup should be. Where did I get that from? It's like way down below the commands. It's such a weird data sheet. It's not really structured very well. It's like, yes, okay, I know all this stuff. Now what? How do I make anything happen on the display? Setup, jumper, here we go. 0 and 1 are baud rate. 2 is select serial IF. J3 does nothing. JRB do not use. Like, what would I have been doing with it? Okay, so let's take a look at the display itself and see what I have set up here. So I set J2, 1, and 0 because I can see solder on the pins. So 2, 1, and 0 here. I probably shouldn't have set them on the other side of the board. I should have set them right here. I didn't do that. We can always remove the display and reset some of that stuff. And then we've got the 7-pin, sorry, 1, 2, 3, 6-pin interface. And then for the 6-pin interface, I've got these jumpers that we can use. So we can keep it on here, and we can move that out to our board so we can do some testing. So I think I have 1, 2, and 3. And with 2 shorted, we're synchronous. And with 1 shorted, it should be 0, 1. Oh, I did, yeah, 0, 1, 2. Okay, 0, 1, 2. So we are 115200 baud, and we are synchronous. Does it have frame buffer for each frame, or must it be programmed manually? That depends on what we decide to do with the displays, I think. Because there's a hidden area that the screen actually has for setting up like a frame buffer. It depends on what how we're going about putting stuff up on screen. And the answer is I don't know. The answer is I don't know. Okay, so case of asynchronous serial and synchronous serial, VCC, data receive, ground, SBUSY, clock, and then reset. And the thing is, this is like one directional, isn't it? So there really is no other communication. It's not like, I don't need this level shifter chip. I could just make a serial in, SBUSY, and serial clock go down to 3v3, and I guess reset too. Well, okay, so let me get jumpers on these pins. Oops, that's not what I wanted. Oh no, I lost my place. Come on, man. We were like deep into the data sheet too. It's like 500 pages down. Or it's right here. No, it's not quite there. Not there yet. Where is that? Nope. I love how they put the whole section about character encoding and what individual commands the display uses in front of how to plug the thing in. It's like, am I supposed to learn all that stuff first? I thought we'd plug it in first, and then we can learn about how to do the deep level character encoding programming. All right, so yellow is going to be power, and then it's 5 volts, obviously. So that one goes into, oh, this isn't our pinout. Those are jumper select. There's the connector. Okay, so VCC is pin 1. This thing has a big meaty connector on it too. I guess I'm gonna have to have a couple connectors on here to interface with the rest of the board. Serial in is there. Let's see, ground is in the middle. It's pin 3. I'm on the opposite side. Whoops, it's over here. Pin 1 is 5 volts. Serial input, I guess I'll just do this wire, brown, and then ground is going to be the black wire. We have Bussy. We'll make that purple. Green will be the serial clock. And then reset will be the repeat brown wire. I said, I'm having trouble plugging it in. You want to check? I can't do it. What's going on? Why isn't it plugging in? I think the pin is bent. Yeah, the pin's bent over. I just need to bend it back a little bit. Give me this pin. The heck? I feel like something's wrong with my brain. There we go. It's like, why am I unable to do that? Okay, so we have 2 brown wires, and I guess I need to figure out which one's which, but let's just get these hooked up to... And are they all going to be 5 volt? Yeah, they're all connections, so it almost doesn't matter. Does it have a processor, or do you just send signals on the display interface? I don't know. I don't know. It has specific commands that the display listens to in a particular way. Okay, we're up here. So this one is power for the display. I'll just go right here. This one is ground. It's a Noritake e-tron VFD. It's the 7000 series. 7003D is the specific one, and if you feel like giving them your details, they will send you a data sheet, and then a representative will email you, which is really weird. All right, so I guess I'm going to go in order for the rest of these. So that would be serial input would be the first one. Thin. Serial input there. Then it's Buzzy, which I believe we made purple. And then it's the clock, and then reset. Which one? Wait, which ones were which? So, oh no, serial in we made this wire here. Yeah, that's this one. So serial input here. Oh, hold on, I'm gonna untangle my mess a little bit here. Here, you guys don't need to be on the microscope. So I'll do these in order. So we go ground, power, and then we have the first pin is serial in, which is this one. This one. Serial in. Then we have busy, which is purple. Then we have our clock, which is green. This is going to get unplugged in like an instant, and I'll just not know where anything is. And then that one. Okay. That's the order of things. Yeah, if I had a right angle connector, I should probably have used it here. If I had female-to-female headers, or wires or whatever for these, then I could put a right angle pin header down on this thing, and it would hold everything together. Okay, so there's that hookup. Now we need to actually figure out what pins we're going to use for these signals. Now, considering this is a Teensy 4.0, I could probably use any pin I want as the interface pins. But in this case, we need to make sure that we're on... I guess I'm going to try to use one of the built-in TXs and RXs. Although there's no RX, we're only transmitting for TX, because we're not getting anything back from that. So I guess we're just going to go with the one transmit pin to serial input. and then the busy pin we're going to have to put to one of the other like D pins. I don't think I'm going to be using SPI for anything, so I think we're game to use something like you know, any of these. Like in2 is also available, that pin. Any of these pins too should also be available. So let's just use, we'll use like 10, 11, and 12. Yeah. Oh yeah, we don't have a PSU shunt either. So that would be Spussy. And then what were the other ones? Oh, SCK. Serial clock. Is there? I mean, there's chip select Mosi Miso. SCK is over here. What a fantastic username. Yeah, we get those around here, huh? Do I want to use asynchronous serial? I think I should use asynchronous serial, actually, because then I don't have a clock. I don't have to worry about serial clock, which means I need to remove the display and get rid of the jumper. If the board was working, that's one to burn. I know, we'll work on the board at some point soon. We'll get that running. I need to get into Python and stuff. It's a whole thing. Okay, so we're going to change this over to asynchronous serial so I don't have to worry about a clock, because I don't want to have to output a clock on a random pin. So that means that I need to remove this whole thing. We can just do, I guess I'll just remove it and undo the jumpers. I should have set the jumpers from the rear. Oh well. Oh well. What do we do when we got this screen working before? I was using ChatGPT to program stuff on the screen, and I don't remember what the hookup was. We definitely were using a 5-volt microcontroller, though. I think that made things a lot more simple. And for the most part, it was able to actually, you know, operate the screen pretty well. We didn't have I2C or anything. We were using the display directly. And it was this display, wasn't it? I think it was. It wasn't one of the other ones that I have. I don't remember. Strange. Yes, so time to unset. We're going to unset J. What jumper are we unsetting? J2 we're unsetting. And we're going to keep it at 115200 baud. That should be a cakewalk for this thing. All right, so J2, this one. There you go. Okay, unset. So now we are in asynchronous serial. So we only need serial to be sent to this thing. It no longer or no, it doesn't need a clock. That's what it is. It's not syncing. Put that back in just so that it looks cool. And magnetic screws, or at least ferrous screws. Laptop jobbies. Hopefully we can get something cool looking today on the screen. I don't know what kinds of stuff we can display, or if we can get things to animate on the screen. I don't know how monochrome oscilloscope displays projects do it. I'll have to look stuff up, and maybe we can cut up another project in order to make it function a little bit. Getting the screen all shut up. So, asynchronous serial. Just around this way so we can see the screen. Look at that. That looks smart. All right, so asynchronous. 115200 baud. This one. What's up, Incredible Mike? Things are quiet this Friday. More of a question of what computer graphics algorithms you know rather than what the display can do. We couldn't even find like a frame rate for the display. So yeah, I mean, the projects that are out there for using displays, there's some good stuff. If you know of any good like screen design things, I was looking at what is that one? LPD, it's something LG, L something or other, LC, some, I forget. It's an acronym in the name. I don't know. Anyway, all right. VCC serial in ground, SBUSY, NC, and reset. So we could just do SBUSY here. Well, here I'll just put pin numbers on the other one. So that would be pin 10. Serial in, we're just going to make pin 1, so we can use TX1. And then reset, we could just make pin 11. It doesn't matter, because we're not really going to be resetting it that much. So those are our pins, 1, 10, and 11. And then SBUSY doesn't do anything. Although I'll keep the pin over here for it, just so that we have everything kind of lined up. That actually goes here. So those go to the level shifter on pin and that would be 1, 2, 3, 4, but it's only 3. So that third one, SCK, is an NC. So it would be B1, 2, and 4. B4, and then VB, VA. Actually, VA is supposed to be 3 volts. VB is supposed to be more than VA. But whatever. This is just for notes. We're just taking notes. Impressed that your writing with the mouse is so legible. I do it a lot. MS Paint notes are something that I enjoy because I get to just draw whatever I feel like at all times. And it just helps me kind of organize projects. So I do MS Paint, and I've done a lot of it. You kind of get practice after a while, but my specific handwriting goes up and to the right just because of the way that I can control the mouse. So anyway, we've got and I've got a lot of MS Paint notes. Like this is a lot. We've done a lot of reverse engineering somehow for this project. This project is, we're building a modular synthesizer tester. It's a module tester. There are a lot of projects that have that have done module tester before. You can buy one because the Mutable Instruments made one, and her design went out to everybody because she decided she no longer wanted to do the synthesizers. That's fine. They open sourced all their stuff, put it out on the internet, and then a lot of these companies copied the design like exactly and have like pretty much the same software. So the capabilities are not quite what we'd want. From our exploration of these A to D and D to A modules and I to S, it seems like the Teensy 4 is a really good platform for this. It's very fast. It can amalgamate a lot of signals, and it can make all kinds of cool audio very easily. So we've been getting that together. It is unfortunately a 3-volt device and not a 5-volt device. So again, like the more we get into this, the more yak shaving has to be done. This is my synthesizer, what exists of it so far. There are some analog modules in there that are untested. There are some digital modules in there that got extensive testing and tuning. But for the most part, it's hard for me to sit down and fix my friend's stuff and my own stuff without having like a module testing module. So in our exploration of what the Mutable Instruments circuits do and what I like and don't like in terms of digital to analog, we've come across a way that we can have universal I/O channels. I can observe 2 channels, and I can output any waveform on any of the other channels because this thing has so many channels to it. I could do 8, but I'm just going to do 6 because I think the addition of 2 more channels is going to make things kind of hard to work with. We have not worked with the screen yet, so that's why I'm focusing on that today. I need to work with this screen in order to make sure that it's going to fit my needs, because if it doesn't, I'm kind of shit out of luck here. I have this nice VFD display that does this really cool stuff. So if I can use that, I will be very happy. So I've got the microcontroller plugged in and I've got it hooked up to power. We need to figure out what pins are going to drive the serial clock, etc. on this thing. And we're going to give it 5 volts from the regulator that will be used to power this device. This is a Teensy 4. The Teensy family is really good. Unfortunately, there was a supply, during the pandemic, there's a supply issue with chips. And so Paul Stoffrigan, the creator of Teensy, was unable to get enough of the Teensy 3.0 chips. He wasn't able to get them for a reasonable price, and they stopped making them or something. So he decided to jump ship and change the technology. And unfortunately, in doing so, all of our voltage compatibility went out the wind. But this chip goes up to 600 megahertz, and it can actually do a gigahertz if you overclock it, which is like, holy shit, I have a gigahertz microcontroller in this thing. But one of the capabilities of this thing is to pump 4 channels of right-left, that would be 8 channels, of I2S audio. Insane, insane. 4 channels of I2S audio and 2 channels of an input. And I could have probably 2 more channels of input if I wanted to. Unfortunately, that does not make 6 channels, so my universal I/O design kind of went a little bit sideways. I had to incorporate some muxes that I happen to have from a brain imager high school internship project. So I have these muxes, these Maxim muxes from the 90s. They're really good though, and they allow me to flip positive, negative 12 volt compatible signals anywhere I want. So with the 8-channel one, I can have 2 reference voltage channels and then the remaining 6 channels of the tester. And then with the single switch unit, I can have the what is it? Whatever this fucking thing is, drop in on the channel or get pulled from the channel. Basically, the 6 channels go to the 6 outs, and then this allows me to unflip that channel from the output so that this is isolated and it doesn't actually swing in any direction because of what it's seeing. Because like I feel like if I put this circuit on here, it would influence the voltage levels because it would get feedback voltage, right? So yeah, I don't know. Just a lack of knowledge of. It's easy enough just to put a switch on it though. But that's what's going to go on there. I need a screen. I need an interface, and we're working on that right now. It's a lot. It's a lot. It's a lot to deal with, and you can see I'm very distractible while I'm working on it. I should just do an art stream where I just draw stuff. I just draw whatever I want. Why is it always that? Control Z. Okay. So yeah, we're just doing pin 1, 10, and 11. So 1, 10, and 11. And A3 is not going to be used. So I just need a couple yumpers that are going to make it all the way over to, well, this side of the board over here. We're going to the opposite side of the board, which is going to be very sloppy, but it's only a couple wires. So I'm going to use the dumb jumpers for this. The ones that I hate. I don't like using these on this kind of thing, but this will just get it to hook up faster and whatever. whatever. So we'll take this one as pin 1. So pin 1 is actually, it's ground 0, 1. So ground 0, 1, so that's on the TX pin. And then the next channel is Zbussy. And Zbussy is going to go to 10. So it goes 12, 11, 10, 12, 11, 10. And then Erst, which is reset, just goes to the next pin up the line. And we skip that one and go there. 1, 2, and 4. There we go, just like that. We had it hooked up for asynchronous, which has a clock, but we don't have a clock on I have the clock hooked up, but it's just an NC now. Sucker NCs don't get connected. All right, so then we plug this thing into power. So I need power. Let's get all the cables out of the way, too. I want a clean setup today. The screen is a nice, clean setup. The software is what's messy on screens. I have not dealt with screens in, like, any of my projects, so I don't know what it takes to drive this thing. This is going to be a learning experience for both you and me. That one's plus 12. This one is ground. And then the weird one is minus 12, which we're not using on this board. I'll plug it in anyway, even though I'm not using it for anything. I'm just going to plug it in for the sake of cleanliness. All right, so there's my little... This breadboard is specifically for doing modular synthesizer stuff, so I've got the plus-minus rails all labeled and everything on it. And this is a new breadboard, which is why it's so shitty. They really are pinching pennies with these things these days. We're not going to be able to see anything off of these screens either. I don't have the power supply built yet. That was supposed to be done. But we ran into another yak. Can you believe these yaks out here? It's ridiculous, and they're all so hairy. I can't stand it. Shave this yak, shave that yak. That yak has another yak in it? Like, what's going on? Where are these coming from? It's almost a joke at this point. Okay, so we've got 5 volts hooked up. We've got our power supply hooked up. We've got a regulator here that is going only to the 5-volt pin of the microcontroller. We've got that hooked up to 3 volts. We've got ground. I think we're good. The OE pin is floating, and I think it can be. And then this thing will just work as a level shifter. To be honest, it's only 3 signals, so we probably should look into getting like a 3904, like a couple 3904s on that instead. Let's get something actually running the screen first, and then we can figure out how to minimize the level shifting layout for the 5-volt screen. It would be funny if I borrowed somebody's like miniature painting setup and I did a whole stream on that, but I had no idea what I'm talking about, and I had to like make up words for different techniques. Just having no idea what I'm talking about. So my output is set to 15 volts. So what I'm going to do is unhook the positive line, both, and the negative line, I guess. Just leave ground hooked up. Turn that on and turn it down to 12. And then minus volts aren't going to matter. I guess we'll just leave it at minus 12. It doesn't really matter. And then we're not using the plus 6. This power supply, this Agilent power supply, seems to have been built for doing like modular synthesizer kind of stuff and like plus minus audio circuits. It's old. So it has positive and negative up to 20 volts, and then it's got plus minus 6 volts. So it's like everything you need to work with synthesizer stuff. I had to get it out of storage. I thought it would be useless. I was wrong. Okay, so plus 12 over here. Bada bing. 100 milliamps, 150 milliamps. That seems wrong. Why are you drawing 150 milliamps? Is that normal? That seems like a lot. Whoa, and then it dropped down. Hold on a minute. Whoa, 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 whoa. Why were you drawing 150 milliamps? Is that normal? Ah! This thing came... All I had to do was touch it, and it jumps out of the board. That's going to be a tough one to work with. Ground to ground. Ground to ground. Plus 12. Plus 12. Minus 12. Minus 12. Oh, minus 12. Uh-oh. I hope we didn't blow up the microcontroller just then. We might have. That might have cooked it. The fact is that this plus line is actually a ground. I may have put way too many volts through my micro just now. That's bad. Well, hopefully you're still alive. We can check to see if this thing is outputting on the I2S line. I'll just get the scope on it and see if it's... It takes a minute to boot up the scope, but... And then let's just double check that this one, the minus line up here is ground. Plus 12 and then ground. And so we've got plus 12 hooked up to V in. Ground is on ground, and then that's our output. This one ground, yes, that is a ground. Then we have 5 volts running over to here, and the 5 volts for the screen is right there. and then our 5 volts runs into 5-volt pin of the micro. Okay. Man, I checked this over twice, and my stupid labeling killed... It might have killed a $20 microcontroller just now. They ain't cheap. I ain't made of money. Why isn't this plugging in? It's like fighting me. Why are you fighting me? Are your clips okay? I think so. Sometimes these boards fight against you, especially the cheap ones. Ah, you son of a bitch. I have more of the microcontrollers. It's okay. I've got like... I think I have one more. Hopefully it survived, though, because I don't think we pumped too many volts through any of its digital pins. I think that was hitting the power regulation circuit. There we go. Now, geez, that thing better grip. Okay. Ready to power it on again. Let's just see if anything bad happens now. Well, actually, power has been on. So now if I put plus 12 in, it's 150 milliamps. Let's turn on the scope. That'll jump up on the screen. And if I plug in minus 12, nothing will happen. Nothing happened. Good. Good, good, good. Okay. Well, this is what should have happened originally, but it's not happening now. With any luck, it'll be okay. We gotta wait for the scope. The scope takes a full minute to boot up. A full minute. Come on, scope. It has so many awesome capabilities. It's just the OS takes forever to boot up. The Android-based OS. It's basically a tablet with a bunch of knobs on it. I decided to splurge and buy the 914 instead of the base model. The CRT ones take a while to warm up. I was at the very end of the CRT era. All of our lab equipment used the CRT scopes, and when you power them on, you get a big meaty power button, and then the thing just goes voomp, and it's almost ready to go immediately. I understand some of the older scope ones. We used to have a tube scope too, and I should have kept it. One that used vacuum tubes. That thing was awesome. Vacuum tubes take a minute to warm up too. You're right. You're very right. Okay, so now we have the scope. Let's put that up on the screen. I think to do that, I go to another camera, and then I go back to this one, and then it goes bonk. There we go. That is a web page on the intranet here. I could probably give this thing the Wi-Fi password, but I kind of don't want to. I probably should, though. I mean, the router's right over there, and it's one less cable that I have to worry about. But this is a clickable interface. It's a web page that one user can open up. I don't think it lets multiple users open up that page. But then you can click on stuff in here and actually change the parameters of the scope. So I don't have to train a camera on the scope anymore. You guys get a real-time, fairly fast interface with this. So it's cool, because it's just an OBS scene that I put a web page on. It really has improved things around here to have that capability. It's been pretty cool. 12 volts, 150 milliamps, no data running out to the screen. We need to check to see whether or not I blew up this microcontroller. So I'm going to get a scope probe. I'm going to hook it up to ground, and then I'm going to take a look at whether or not this thing is outputting I2S, because that's what it's programmed to do right now. We use this for the 6-channel I/O test. So channel 1 I got hooked up, and it's on the millivolt scale, so we need to up that a little bit. 1, 2, 3 volts is fine. And then this goes to ground. And then we look at the I2S pins here. That's not good news. Is this at 5? That's at 5. This thing is now at ground. Oh no. This is not good news, folks. This does not spell good news for my micro. This thing was programmed to output I2S. And we get nothing. We didn't even get a power light from it before, though. But I2S is just like an output thing, so I think we're dead. We might be dead in the water. Maybe if I plug it into USB, it'll magically come back to life. Please, you have to come back to us. I can't believe Stoffergan didn't use a USB-C port, though. USB-C would have been nice on this microcontroller. That's kind of annoying, because now I have to look for a cable. Have you run the Linux distribution for the RP2350? What? Why? Why would I do that? Why would I have done that? Just gotta ask yourself. Is that something Bother would have done? Run the question through your head. I don't have any RP2350s. Is that what the Pico Pi is? That's a 2040. I need to get a cable. I thought I had one, but I don't know what happened to it. I had a USB-C cable around here, or a USB micro somewhere around here, but I don't know what happened to it. I gotta find it so I can program stuff. Oh, it's right here, sitting right on this, right on the breadboard. Okay, so get this thing plugged in. It's a real roundabout thing. The USB comes from the streaming computer right there, the one right below the Twitch TV of Bother thing, and then goes out that rack through a plug, then across the back of the desk, and then over to this 7-port powered USB hub. It's metal, and then around behind the desk to the Steam controller plug right there. So I can't run too long of wires through this, or else the micro doesn't end up communicating with stuff. Sorry, I'm tightening the camera right now. It's a bit of a roundabout, but it keeps me a little bit more organized. So if I plug this in, it should show up here. Let's just open up Arduino because we're going to need it in a minute. RP2350 is the micro for the Pico 2 with 2 cores ARM RISC-V architecture. Did you just read about it and then decide to ask me if I've ever used it before? Because that's a really weird... I don't know why you guys do that. You guys always do that to me. You see it in like a Hackaday article, and it's like the newest, greatest thing, and then you come in here and ask me if I've done anything with it, if I've used it for 5 years already. It's crazy. This is from the audio interface stuff that PJRC has, the website has. It's pretty cool. You hook everything up with like cables, and then this uses those cables in order to hook up your various functions. So we have patch cord 1 is connected from this thing to this thing. Cool stuff. Board. Oh, it sees the board. TNC4 serial 600 megahertz. Or no, no, never mind. It doesn't see the board. There's nothing in port. Never mind. It's dead. We killed it. Damn it. That was a big mistake. That was a big stupid mistake that I just made. This thing is dead. Here, let's pull this and see what we got. That sucks. I wonder what dies in these things, if it's at all recoverable. Yeah, nothing. This is why we double check. This is why we double check, and sometimes we don't get our double checks don't work. All right, let me turn off the power supply because it's claimed another victim. I should put like marks on the side of it for all the stuff my power supply is broken. I'm special, my viewers are too. You know how it is. Darn it. Dead micro. What would have died? I mean, we hooked up ground to -12, and then I had 5 volts on 5 volts. So basically, I gave it way too many volts. It might be that the regulator died. Might be that the regulator died. I'm not sure. And I don't know how I could possibly tell. Well, it goes to the dead pile. I'm going to put a big X on it. Big white X for dead. Where's the white marker? Where'd it go? Ah. All right, so we're going to take what do I have here? I had paint markers, but they left me. They're in the drawer. Yeah, here we go. We can use one of these. I think these will work. Nope, doesn't work at all. Whatever. There's an X on it. You can tell. Rest in peace. Yep. Dead micro. Son of a bitch. I only have a couple of these because they're expensive. Nah. I mean, I could put one of my TNC3s under the knife, but we're supposed to be testing this in regards to hardware that we're going to be using in the future. So, I mean, while these things are great as sort of the tester kind of things, I probably shouldn't, because it's such a specific microcontroller, we probably should move over to this guy right here. I think I have 3 of them. One of them's already out and over here, but yeah, this will be our test mule. Get a new one off from the pile. And now I need to find square headers that are going to fit. Better I use the easily popped out headers, the miniature ones that were, yeah, because then it'll be a whole bunch of soldering if I don't. So I'm going to solder this down to the headers that I will inevitably use, the little circular ones. That's going to make it way too easily pop out of the board, but it's just something that I'm going to have to live with. I would have had it for having one that goes into the end device and then the other one just stays on breadboards, but we blew that one up. I mean, shit happens in the shop, right? This is a totally normal thing to have happen. This is why you buy multiples. It is frustrating, though, because I was trying to be careful, and I ended up running into the problem that I knew that I'd run into, which is the fact that all of the red trace is the one at ground potential. I should tape over the end of this so that I have the labels there. Oh no, I broke it off on the wrong pin. Son of a bitch. Stupid thing. Yeah, I guess I'll use the wire cutters. These are cleaner. It's been a while since anybody has done anything with the drop command, so I'll let that slide. Usually the drop command is for when it hits the floor. That was suspended in my jeans, and I was able to get it back. How's it going, Wayne Johnson? Having a bit of a quiet Friday. Hopefully we're going to get some screen stuff actually running here. So you can see how cool this thing looks. Yeah, that command came about when I was working with MakerBeam. And the thing about MakerBeam is there's a lot of little screws. And so I was dropping stuff left and right. And I was like, well, this would be funny if we had a drop counter. That was when I was first building Burn the Subs. That was the first iteration of Burn the Subs being built. These do not like to stick in, do they? These are very pop-outy on the breadboard. There you go. Oh, sweet. Finally, we can buy some viewers. Is this economically viable? Like, is that actually economically viable in any way? Do you still have the original board? Yeah, the old boards, here, take a quick aside and take a look at that. The old boards are, actually, no, you guys are not allowed to look at my desk right now. My desk is filthy. They're the backing of my desk. So you can see in the very corner of the screen, you can see that these 2 boards are right there. There's one there and one below it. And those are the old boards. I've got lights on them too that I need to hook up. But what I should do is have, instead of having the boards behind the monitors, the board should be to the side of my desk instead of behind, because you can't see the boards. The monitors block them. And my desk is absolutely filthy right now, so I don't really want to show it off. Okay, let's do this. Let's get to this. Let us do some ASMR, visual ASMR soldering. The name's ASMR. Don't get it wrong. Okay, so a little bit of this, a little bit of that, some solder. Let's get that over here. So perforated prototyping, or sorry, solderless breadboard is really good for setting up stuff like this, because what you could do is use it as a heat sink. It'll absorb all of the extra heat from your solder and keep your pins from going all jacked up, getting all weird and bendy. And it makes sure that everything is at right angles, and it holds stuff for you. It's a good. It's not just for prototyping. The interface to this board is great for lining things up for soldering. I can see that that's crooked, and I'll fix it in just a second. It kind of fixed itself. Probably shouldn't put my fingers on that side of the board. There we go, that's a little better. Doesn't need to be super perfect. Future perfect. Past perfect, future tense. Now, really, the proper way to solder something is you hold the solder on there for just a little bit, and that allows it to heat up and propagate into the pin. Because the other side should have solder on it in order to have a proper joint. It's not terribly important with this specific setup, but it is, you know, if you want to do stuff properly, you got to hold that heat there for just a little bit. But I've done soldering tutorials. Basically, we're trying to heat up the pad and the pin, not the iron. We don't care about getting solder on the iron. We want to get it on the pad and pin. So technically, this was the proper way to do it, although you can see I messed it up a little bit there. Just add a little bit more so that we don't have... They're not really supposed to bulge like this. They're supposed to actually sort of sink in a little bit. But it takes a little bit of extra time if you're doing it this way. So what I do is I apply the solder really close to the iron, and that little bit of flux that gets on the iron and the pin and the pad holds heat in and allows it to allows the heat to propagate throughout the rest of the stuff. Now I'm getting a little close here. Let's get some more solder. The thin solder versus my spool. The spool is a little bit heavy, and so if I pull the solder directly, it sometimes snaps. So I have to like manually advance the thing. Yeah, just like that. And you'll eventually get the practice of soldering by soldering. One of those things. You get better at it just by doing it. Of course, it also helps to have really good vision of what you're doing. And I do that through my microscope. There are other ways to magnify what you're doing. One of the better ones is looking up stuff for, what is it? Needle stitching, or whatever that's called. Needlepoint, there we go. Needle pointing has become pretty popular over the past couple of years, past many years, and the pandemic also had a boon of stuff like that. So all these ladies doing, all these people doing needle pointing have terrible eyes because they're old. So actually there are younger people that are into it. But anyway, people need magnification to see what they're needle pointing. Needle felting? No, that's different. And so there are these magnification headgear that people buy and use, and they're cheap, but they do a really good job of really giving you a close-up view. That old 1980s magnifier, I used to have one of those. I should probably find it again. The one that you always see around electronics. It's like that, but it's got a little headlamp built into it. It's really, really good. If I were doing this on my own, for a little while, what I would do is put on a headlamp and then have like a jeweler's loop that I would use to see stuff up close. And I was looking into getting some of those like dental optics where you've got like the Zeiss lenses on a pair of glasses. I was going to look for those to do this work, but the microscope camera needed to be something that I could broadcast, and that's how I kind of came across the webcam with a Nikon lens, and it worked perfectly. Jeweler's loop for looking at part numbers. Yeah, that gets you up close. Nice and easy. I've got a couple. I think one of mine is actually a legitimate jeweler's loop. The other one is a little stand from Radio Shack that holds it just has a big plastic lens on it. Man, that's going to be a thing, huh? In like a generation or two, you'll have people doing hardware that are using like the rarest of rare tools, and it's like a little plastic thing from Radio Shack. We don't have Radio Shack anymore, but I'm sure a couple executives made a lot of money. Like more money than God. So that was totally worth it. We might have the same one. If yours folds up neatly, that's the similar to the one that I have, and I don't know how I got it. There's like a distribution system for those things. They just kind of show up in electronics shops. All right, microcontroller number 2. May luck shine upon you in your future endeavors, microcontroller number 2. You do not have an enviable task ahead of you, and that's to survive my shenanigans. Love me some golden parachutes, yeah. The investors made a lot of money, so it was totally worth not having a local Radio Shack. All right, so this one is going to live inside of the device, but we're going to have to work with it on the breadboard. Now, these circular pins instead of the square pins, they don't get along with this thing very well, as evidenced by this voltage regulator. Every time I bump it, it wants to pop off of the board. So we're going to have to be careful. And I'm going to have to be careful not to overvolt the whole goddamn thing. I wonder if, because like it's a very specific overvolting that we did with this one. I'm wondering if maybe only the PSU died, because it shouldn't let anything by because I was going into 5 volts, right? So we had an electrical potential of -12 to 5. That was 17 volts into the 5 volt input. We did 17 volts into the 5 volt input. My city is now down to one local electronics shop that sells questionable parts that may or may not be legit half of the time. That sucks. We happen to have a Micro Center near us, so Micro Center is the place, and it is the only place to go because we don't have Fry's Electronics or anything. Yeah, this little guy right here, this little voltage regulator, got 17 volts. Which really, I don't think any respectable voltage regulator should not have... Let's check the specifications for the teensy voltage regulator. I wonder if it specifically died, or teensy for over voltage. Over voltage for analog, 3v3 power supply. How to protect from higher voltages, development board. Killed 2 teensy 4.0s with this circuit. Create a circuit for a senior design. Hey, at my uni, circuit is meant to receive a small signal from contact, control an H-bridge, send a frequency. Testing the circuit, we programmed the teensy to do PWM sweep. When the board was turned on, teensy booted up, began driving the motor. Circuit is 3S LiPo. I don't know. He said he overvolted it, but he didn't really describe a problem. Oh, I see. He's trying to figure out what killed it, or who killed it. Did you breadboard the circuit? None of this. Hold on, it's going to try to share my email with the whole class. We'll go to pay.reddit. The minute they deactivate pay.reddit, I'm done. I'm cooked. This is too basic of a question. I'm just wondering if anybody has had this problem before where they overvolt a teensy, and if there's a way to recover it. It was at 100-something milliamps. Because 5 volts goes in there and to the USB, right? And then it also goes to only the regulator. And then the regulator would have sucked that down through ground and blew up. But I don't even know the model of the regulator. I need to look at the design of the teensy. No, it didn't do anything dramatic. Okay, USB micro B, VUSB through the jumper, V in pin, goes through a 500 milliamp ferrite, or sorry, a 500 milliamp fuse, a ferrite, and then it hits this FET. Huh. And then it goes right into the teensy. Ugh. Oh, that's bad. USB V-Bus 1 and 2, huh? Yeah, so that tanked the micro. That sucks. First stop, the microcontroller. That's bad. V shit. Ugh. Well, there's 3 volts going to a bunch of stuff. And then all of these, VDD, etc., etc., etc. So yeah, it definitely killed the chip. That sucks. Okay, well, anyway, now we know it's definitively dead. It definitely just lunched the whole thing. Nothing got dramatic, though. Nothing heated up too much. Nothing really showed any signs of anything. It died like a bitch without exploding for us. Oh, that was the wrong one. Sorry. I'm sorry I called you a bitch, but this one died like a bitch. Okay. So hook this thing up. before I hook it up, maybe I should test just make sure. All of my confidence is gone. $12 volts, 150 milliamps, and that's what the screen gets. And then let's do out a couple so that we can see 6 volts there. So now we have 6 volts. This is just noise, electrical noise from floating pins. So we take a look and we see that this pin should be at nothing because it's at 3 volts when it functions. This thing is at 5, between 4 and 6. And then this one is at 12. So that's off screen. This one is definitely at ground. Okay, so we're good to go. Oh yeah, and then let me make sure there's nothing is going on this pin. That is in fact ground. All right, so now I can put the microcontroller on this and it won't blow up. And if I turn this on, I'm going to get like 100 milliamps, 180 milliamps, and the LED turns on with Hello World because this is the first time this thing has ever been powered. Hello World for microcontrollers is just blink an LED once per 500 milliseconds, I believe. One Mississippi. It's maybe once per second. That's Hello World for a microcontroller, and it takes a lot to make us do. Takes a lot to get Hello World onto your micro. So, now that works, I can actually test 3 volts. Let's make sure 3 volts is good. So put ground in, make sure it's ground, and then test that this is at 3.3 volts. A little bit below 4 volts. Perfect. Okay, so we've got all our power in here. Presumably we're hooked up to serial. Let's get some code onto this micro. This is the daunting part. This is the part that I've been avoiding. I need to reposition myself so I can use the keyboard now. And we can try to get a Hello World running on the Noritake e-tron display. Now, Paul Stoffergen has a library that utilizes, well, it does bit banging timing in order to do software serial, and we don't really want to do that. But if I actually open that one up, it'll tell us how to boot up the screen and get something to display on it. So we're going to start there. What are we doing? Examples. And then we are in, I think, not liquid crystal, LED display, LED control. What was that called again? It was like the teensy Noritake 2812. Oh, GU 140 7703. Brightness on off, clear redraw, clear change. What GU 700? And then hello. So we're gonna piggyback off of this, and we're not gonna do bit banging serial. We are going to hit this thing up directly with serial and actually speak to it, because this one had all kinds of trouble with it that we had to look into to try to fix. But let's just get this running at its most basic. And actually, to be honest, maybe we should go to the examples from Noritake. Noritake. Say it with a very heavy American accent. These Noritake guys are making good screens. Noritake. Oh, we have electrical design good 10K. The GUD is a digital design tool to help you put together the screens, and it was made in what looks like Windows 3.1. And I don't know if we're going to use their tool to put together the screen. I just want some basic code in order to take a look at how the screen is functioning. So I don't think we're going to use this. Let's just go back to products, and we're looking at VFD dot matrix graphic character. They are some good looking things. They look nice. And then we're going to look at customer support tools. I don't know about that. A guide to VFD operation, Arduino code library, quick start guide. Here we go. Get out of here. GE7000, GUD, CU, CUY, or GU7000. What screen do we have again? Whichever one's in here. I had two of them. This design is so good that it was like super flat. No. Not the internet's favorite new word. GU7003. GU7000, there we go. GU7000 series Arduino library. Didn't we already do this? I think we already did this, and it didn't really work out all that well. Yeah, we did. It doesn't work on the Teensy, I don't think. Plus using delays. Well, I mean, we can try it. I don't think it's really going to work, but we could try. Yeah, Sin, Bussy, and reset. Okay. I mean, we could try it, and we could hook up one of the I2S audio things and see if they're compatible. So we already have this library, and we already have our setup right here. And this says vfd.print void loop. But I think if I try to compile this, so G7000 asynchronous, and it's pins 1, 10, and 11. Look at that, I actually memorized something. I feel so smart. That's 115200. Cool. Control Z. It totally blew away the whole line. No, this is a GU7000, but it's not like the other GU7000s, not like other girls. It doesn't have anything but serial interface. So we're going to try the GU7000 library, but it probably won't compile. Teensy 4 600 faster, US English, no port. Oh yeah, let me plug it in first. Gotta plug in the actual display too. Oh, wait a sec, this thing isn't plugged in properly. There we go. Had a home row error. Home row errors can kill your microcontrollers. You gotta be careful. Always keep your head on a swivel. All right, so let's try uploading this code and just see if it works. I'm a little wary. I don't think this actually compiled properly last time. It had all kinds of weird errors. And we were monkeying around with it, and it didn't really get it to work. Yeah, error compiling for Teensy 4. So what we need to do is we need to start a new program. So file new, and let me get my key. Once again, I'm crowded out of my own keyboard because of the way that I work with stuff. Everything creeps over to the side. It creeps. It's creeping. All right, we don't need the scope up yet. Well, actually, we might actually need the scope. But let me get everything out of the way here. Let me move over. Just got to be careful about what I'm doing so that I don't blow up another $20 microcontroller. This has been an expensive day so far. I'm gonna have to go order some micros this afternoon. If I'm gonna be coding, I need a little bit of space to sit here and plug away at the keyboard. There we go. Give that mouse plenty of room. Okay, I feel a lot less crowded. All right, so we are not going to be including libraries. What I'll be doing is, and we'll just do start off this program. The display is for a module testing module for Eurorack stuff. And so what we're going to be doing is outputting 6 channels of I2S. We're going to have a screen. We're going to have an encoder. We're going to have buttons. Everything, right? We're going to have all kinds of stuff. Now, we did some AI testing, right? Yeah, Noritaki Noodlin. Was this it? I don't know where I saved my work from that day, because we had the display doing stuff. And I want to do the minimal amount of stuff that it takes to get the screen to work. No, this is us from the other day. Only thing I don't like about what should order an ESP32. Why should I order an ESP32 board? What? No, no. I'm not just gonna use it. I have plenty of microcontrollers if I wanted to go to another platform. I'm not gonna switch platforms just because I launched one single microcontroller. I'm not gonna give up that easily. The reason that we're using this microcontroller, and I've said it 1,000 times, is that this thing is super duper duper fast, and it does I2S audio stuff very easily. I don't know why people like come in here and try to sell me on the thing that they use when I've... I just don't know what to say to that. I don't know what to say. Okay, so setup and loop and all that stuff. We need to set up serial and everything. So... And I'm actually, let me just take a look real quick and see if we have stuff from when we were doing the AI programming test, which would be in my, let's start at the desktop because there's a link to the projects folder somewhere around here. Stream. Really? Ugh. Oh no, I have to go in through... Yeah, that's right, I have to go in through this. Oh, I think that's the wrong one. Yeah, that's the wrong one. Windows is a little weird about this stuff, and it doesn't like... I think it needs to go directly into the IP. All right, yeah, there we go, project. See, and there it is. So under stream, do you have anything that says like AI or brewing, channel point, chatbot, Neural Johnson? That's a different project. That Neural Johnson is something that Milton T. Pike, who's back after a 20-month break as of today, Milton has in his chat, and it's like a neural network bot. It's pretty crazy. I'm also super fast and do I2S stuff. Me too. EQ settings, fonts, GDM light, the something joystick, Cayman filtering, letters, links, meme, Merc wheel, bump, 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 RC car, Tasmo lamps, 3D printer. I guess I didn't save any of it. Yeah, it doesn't look like I saved it. The fart thing will come back. Do not worry about that. It's just a matter of getting an MQTT broker, because I'm going to move everything over from being individual Twitch bots to having one singular input location from the rest of my shop. So we will get back to chat level interactivity. Don't worry about that. It is of a priority. I need to get it done. It's not a matter of me doing work. It's a matter of figuring out MQTT stuff, and it'll get there. We just need to be patient. So none of this stuff sounds like the AI thing that we did. I thought I would have had to have saved stuff. In order to upload code. So it's got to be around. It might be on this local computer. Something under like screen stuff. How long ago was that? That was like last year I did that. Oh, I recognize the name. It's not like I've forgotten. How's it going? Commander Kellogg's. Yeah, the channel point fart thing died because its credentials lapsed. It's been a while, and I'm sorry, but we'll get it back in like a month or two. Okay, so it would be this PC, and then it would be documents, and then there's an Arduino folder, and then we have all of this stuff that I didn't feel like saving, including the thing that we worked on last time, but that's not what I'm looking for. I'm looking for the AI-powered programming. Tiny 8 analog write test theme, sample VFD, pulse, pin 5 test, packet test, Nortec Nodalin, hello world, Dewey, brute forcer, constraint test, basic PWM, and Arduino basics. Yeah, it's sample VFD is the closest thing I think that we've got. Let's see what that is. We've had to fart in chat, what feels like years. You guys have had to be polite, and that's difficult, I know. This is using the same library, so we can't use that library with this microcontroller because it's something about it. It just doesn't like it. It doesn't do it. So let's start picking this apart. And actually, for that, I would like something else that uses serial. Large text demo, character sets. These are all screen things. Let's packet test. I need a serial example because I forget about how everything works. I just don't remember things. We'll start throwing this together. Programming. How much fun is programming? Shouldn't it be really, really fun? CRC 16. Oh, this is for other, and this is using software serial. What were we doing with this? What was this? I guess this was me making packets for some other type of interface. Ha! Thank you for recognizing me. As strange as that sounds, not been having a good time recently, so I came here because I remember enjoying the time with you in chat. Oh, thank you. Look, I've got a decent memory for some of the weirder names that I see around. Let's just open up an example. You guys give me all of this, you guys think I'm some kind of buffoon out here streaming, right? I'll have you know that I have a little bit of permanence, object permanence at least. We're doing serial communication, so that should be on its own thing, right? Communication, serial. Whoops, I think I opened a virtual controller, which is not what I wanted to look at. Or maybe I clicked so badly that it didn't open it. No, there it is. Analog sensor, this is virtual color mixer, apparently. No, we're not doing that. File open, our examples, and then we're going to basics, and then serial, right? Analog read serial? Sure. It's not like I don't know how to do it, I just don't, yeah. Serial, I think we're doing serial 1, begin. So, where are we writing our code? Not in Hello World. Did I just close the new project window that I had open? Yeah, I did. Well, let's go back to VFD noodling. Yeah, we'll go back to this one, and I'll blow away the project and start over. So, all y'all gone. Get rid of it all. And we'll take our inspiration from, whoa, what the hell is this? Oh, this is how we were doing it before. We were actually still using their interface. So this was us getting AI to put a picture up on screen. And it turns out that all of this is just made up junk. This is all just junk. What up, Flask? How you doing? But we can't actually get this to work with, yeah, here I did the marquee, I've lost control. We can't get this to work with the Teensy 4 for some reason. So what we'll need to do is go into the library and figure out what vfd.begin does and just redo it. So we're doing this from scratch. Screen layout designer.h. Huh. And then we're not declaring that, and then we're getting rid of all this. And then we don't have this object or any of that, and we're not using any of these. Screen layout designer.h we also don't need. Delete. Okay. Back to basics. Needs the processor, so no delay. Okay, so what do we do when we start up serial.begin, right? In this case, they have vfd.begin, but we need to do serial begins. Nothing more intimidating than starting with a blank sketch. It's tough because you question everything. You're like, wait, how do I structure things again? I need to open one of my other programs. So I'm just stealing this stuff. I mean, I should probably grab all of this. I'll just copy this, and I'll put all of this in here. This is the wrong one. Just so that I have all of my structure the way I like it. So in the loop, we're not going to serial print line, serial begin of serial speed, and serial 1 begin serial 1 speed. And then over here in settings, define serial 1 speed. And AN vtest, we're not doing that. Define, oh no, I shouldn't need to define the serial output, but I'm also going to need, the pins are going to be this bussy, which is pin 10, and then define reset 11. And then bussy and reset, and then we go down here and we've got this audio stuff that we're not going to do right now. So I'll just get rid of that. Pins, pin mode, bussy as an input, pin mode, reset, input, no, output. Serial begin, serial one begin, void loop functions. Okay, so, oh man. Serial stealer? What? Working with two serials at once, I think all I need to do is serial one. There is an example that I could look at. There is a communication example where it's serial pass-through. So we'll take a look at serial pass-through really quick and just see if there's anything that I missed. As soon as it opens up. There it is. Yeah, serial one dot begin. Cool. If serial available, serial write. If anything comes in serial, if serial write. So that's the buffer reading back, and then if serial's available, then it writes it to the other one. So serial dot write, I just throw over like that. So cool. All right, so we can send serial signals at 115200 baud out of the asynchronous serial pin. How does that function? This is module tester. We can close that. We'll open it up if we need it again later. Analog reads serial. That's not something that we really have to worry about. Let's close that. Let's set up the VFD. Oh, this is the sketch. That's where that went. I was looking for that earlier. Save changes? No. We've done more writing now at this point. So we've got all our pins defined. Now we just need to follow the way things are supposed to be done. I gotta be careful about, because I want to quote the Office linebacker commercials, but there's some kind of a bot, and I don't know how the F it found my channel. I quoted that commercial, and a chatter shows up to my channel, of all places, right? Love the in-app examples, saves me from hammering Stack Overflow servers. I can't program without a good example in front of me. I don't know why. So this, we need to piece apart what this is doing. Yeah, isn't that weird? It's like, of all places that you would find something like that, you would think that like if an advertiser was actually able to scrape, I know, those are great commercials, but like, first of all, they're no longer working with, well, maybe they are still working with Terry Tate. I don't know if he's still doing commercials for like, whatever, ESPN or whatever. But like, I don't think the money is still there for them to fund things like that. So it might just be some person. You killed the Joe, you make some more. So how did they find my channel? It must be somebody who made a bot that scrapes audio and translates it, or maybe it's through the subtitle engine that Twitch has running. And no, it wasn't from, no, this was live. This person showed up like seconds after I said the quote, right? So there's a little fuzziness in there, but it's probably something that's monitoring whatever is translating audio or actual audio into text or something of that nature, and then they jump into my chat of all channels and make a comment. I mean, we're in science and technology, and we're not that popular. I may have partnered, but only by the skin of my teeth. I really would like to grow the channel, and I have absolutely no idea how to do that, aside from risking bodily harm and injury. I want to continue to do what I want to do, so I'm going to keep doing, but I need to come up with some kind of a thing that I can do that'll grow the channel a little bit. I love you guys to death, but I wish there were more people in chat. I don't think it was a copyright claim. Because it was just it was like a Terry Tate account. I just picked a scab. I shouldn't have picked that scab. Hopefully that doesn't bleed. I hate it when I'm like dripping blood on camera just because I happen to scratch a scab off of my arm. Okay, so let's figure out what's going on with VFD.begin, right? So we're going to need to get into this. So we need to go into my libraries, which are stored in the balls. No, they're actually in the documents folder, not in the balls. Arduino. And then we have our libraries folder, which is in our sketch folders, which is a weird place to put it. So we have the GU7000 series and the GU140x32-7703A library, which is sort of very hyper-specific. We should probably go through the, oh god, there's a couple. Oh yeah, because we were going to rewrite the library to work with the Teensy, but it's better if we just do it from scratch. This is the one that we were using though, GU7000. So what do we do? VFD.begin, and that's probably from interface. Oh, these are all my VOD descriptions, huh? I got to get back to doing that. That's a chore though. This is not correct. Oh, virtual void init equals 0, right? Uint data, and then hard reset. Those are the three functions that I guess we need to program. Serial async. Public async. Baud rate out busy. RX checking. This is going to be tough for me to figure out. Bit delay, SCPU, baud rate 4. TX delay, subtract cap bit delay 15 over 4. Is this bit banging? It's using like a bit delay function. Oh my god. That's way specific. Okay, raise reset, direction out, direction reset, direction bussy. Did you get an error with Teensy? It just doesn't work. We get an error, and it does stuff that is going to interrupt our I2S stream. So we can't use the methods that this... yep, no, big spot of blood. I've sprung a leak. One sec. Paper towel for this. I've sprung a leak. Yeah, the way that this thing is doing stuff, it's especially with this kind of stuff, this little like digital pin to PCIR out or whatever the hell this function is doing is RX delay, centering, subject cap, bit delay, and then the bit delay was using like weights. The Paul Stoffrigan one was the one that actually used the weights. So I'm not sure if this will work or not, but we had like a fix from PJRC in order to get it working on the Teensy4. The Teensy4 is still relatively new, so a lot of the libraries that worked with the Teensy3 don't necessarily work with the Teensy4 because the controllers have different features. The different chips have different features on them. So it's better that we just do this directly and that we don't use software serial. We want to use the hardware serial engine, which is why our TX has a specific assignment. All right, can we stop bleeding for just 1 second so I can get back to programming? What, let me see, hold on. Arduino, well, do they have one that doesn't use a library? The Noritake has, yeah, they use their library, which doesn't work with the Teensy4. Upload to Arduino. They give you the basics so that you can hit the ground running, but this unfortunately, these guys here use... And it would be nice if I could use like I2C or SPI, but my screen doesn't have that. The specific model of screen I have only uses asynchronous serial. Arduino, Noritake display. Let's put VFD in there. Serial. At least a lot of people are using these things. Oh my god, so many things popping up in my face. What? I asked them for one to work with and they gave it to me. That's you could just do that? All right, so he's got a 2x6 character display. Probably use it just like a regular old character display, which is not what we have. We have a different interface. CMOS and RS-232. Plus minus 15 volts. What? How are you hooking up to it? You're using their 6-pin interface. 10-pin top center. VFD comes pre-configured async mode 38400. It's necessary to use UART to talk to the VFD. Any GPIO pins will suffice. Minimum of 2 pins are needed for SYN and bussy. Third GPIO pin can be connected to a reset output. The writing speed of VFD is very fast. Running an async on Arduino Uno at 38400 baud, I was able to put 120 characters in a mere fraction of a second. Yeah, well, microcontrollers are fast. I hooked up mine to an Arduino as follows. Pin 1, pin 2, blah, 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 blah. So we're all hooked up. Oh my God. Really? You dedicated an entire image for an any key joke. You sicken me. What's the appeal of VFD for the specific project? Absolutely nothing. These displays look cool. If it was, you know, what I should do, I should have had a touch screen interface, and then I could have used one of those touch screen designing tools in order to make all of my interfacing for this project. This is just something that I happen to have. They're expensive, they look cool, and they would look especially cool testing out modular synthesizer modules. You know, I've got the power supply down here, and then I've got the module testing module, and I thought it would be really cool if this had a particular look to it. So while this is a little bit of extra effort, and while it does limit me to 1-bit color, I think it's cool to have, and it's fun. It's a fun little appealing, cool thing. Yeah, always the rule of cool with stuff like that. Exactly. You are exactly correct. I am bleeding all over this paper towel just because of the stupid scab on my arm. Ah, this person uses the library. Ah, come on. Yeah, well, somebody like this would use the phrasing in a mere fraction of a second. You can. This is a type. You can tell this is... Actually, is that my torso? Okay, anyway. All right, so they're just chickening out and using the library. Damn it. Okay, so I'm not going to spend a ton of time doing that because I think we could just send it serial stuff. We just need to raise reset so we can make a function here, and we'll do, wait, where are we? This is sample VFD. We're not worried about that. We're noodling right now. So we go down to our functions and we do void VFD init. And that's not going to return anything. So in setup, we set up our pins, we set up our serials, and then we init, and I do VFD init there. That! No! Curse you, insert key. VFD init. Do I have to put the parentheses there when I do that? I forget how to use functions. I'm that. Yeah, I have to do the parentheses. So let's see. We've set out 1, reset, and bussy. So out and reset are outputs. Bussy is an input. Get mode class 7003, 7 blah blah blah. Inverse logic is 0, and then we raise the output pin. So when we init, we do serial write. No. Not serial write. I don't remember how to use an Arduino. I think my brain is finally broken. Where's I'm just gonna look at Blink real quick. It's digital write. That's right. Okay, now I remember. Digital write, reset, and I called that S reset high. Set that pin to high. Yeah, digital write. It's dumb. I can't believe I forgot that. I find being watched while typing, let alone programming, incredibly debilitating. Hey Baloo, how you doing? I learned Python. I'd never coded with Python. I've only coded a little bit in like C at that point, and Arduino, which is kind of it's C plus minus, not really C plus plus. And so I decided to embark on a journey of learning Python with chat, and it was insane. I had a lot more viewers back then. They all died. They all died from my programming. So we're going to run VFD init, but VFD init's one of our own functions, and it's one of our own functions that's going to do the same thing as the functions that are built in for the Noritake library. The Noritake library can help you get just a regular old Arduino running their code very easily. The only problem is we have a special microcontroller, and our task is also special. It's not what you would think. So unfortunately, we need to send special stuff to our screen. I should have been there. I could have learned along with you. I can't code for shit. You know, when you have projects to kind of motivate you to do it, you end up kind of learning it eventually. Python is interesting because of all of the white space that it uses, and people seem to hate the white space. I don't mind that. If you get your IDE to show you what all of the tabs are, things aren't too bad. But what Python eventually teaches you is sort of and maybe it's just because I started with C and cut my teeth with C, but you end up kind of like thinking in the way that your code executes. It becomes more of like a spoken language to you, and you sort of think through the problem the way you would think through a problem in English. You would think you kind of structure your Python code. It's interesting that it does that, but it also teaches you bad habits with semicolons. You're a hardware guy, not a software firmware guy. I get it. Yeah, I got pretty good with it though. Yeah, it teaches you some bad habits, like not naming your variable types and stuff like that. So VFD begin. VFD interface. Selects the interface to use. VSD is model class. So we're just telling our own library what we're doing. Reset the module. VFD GU 7000 reset, and then init again. VFD begin and VFD init. So we have to figure out what these two are doing. VFD init is going to be the one that does a lot of stuff. Python's so much better than hunting down missing curly braces. But then you're looking for missing tabs. It's like 6 to 1, half a dozen to the other. Oh, you know what? It's Notepad++. I've been looking for that. VFD init would be this. So we set up the pins. We raise the reset. If get mode class is 7003, why is raise out? Raise and lower. Huh. TX pin right. If pen state is equal to low, transmit port register and transmit bit mask. What the? I thought there were some other commands here in order to set up the display. 10,000 lines of BASIC is a Futurama quote that's stuck with me for a long time. Hard reset, lower reset, delay, raise reset, delay. If get mode class 7003 while check busy, not while check busy. Okay, weird. So that's the serial async interface. It doesn't seem to be all that complicated. So theoretically, everything is ready for us to give it serial code. The rest of this is just defining stuff. Let's just see, is there another function in this folder or set of functions? I think for a lot of it, it's just setting it to that's synchronous serial. Keywords, methods, VFD 7000 rather. Set cursor, carriage return home, line feed back and forward. The rest of it, I think, is just setting up the library. And so since we know what we are, LED color. We don't have an LED behind our screen, unfortunately. JavaScript can be used with most semicolons now, but I still use them, and ugh. JavaScript. Oh, chat was mad at me back when I learned about the differences between Java and JavaScript. They get mad. Oh, sorry, you can do JavaScript without semicolons now? Just using an IDE or Notepad++ set up right. Yep, that's what I do, because I can't be bothered, because everybody has their opinions on what IDE that I should use, and they all suggest that I do it. No, I'm already doing it my way. So I have to do it the most cursed way. What the hell? I think I just have to be cognizant of what the size of the screen is. I don't think a lot of this stuff is really useful. Print number unsigned long, blah, 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 blah. Where am I making packets? Oh my God. Back, forward, carriage return, use custom. Oh my God, that's a lot of stuff. These are a lot of functions in here. So we need to look at VFD .print. Oh my God, there's all these different types. And that's going to be in here, right? Oh my God. Okay, so let's find print character C. Void print. You cannot be serious that nothing says print. That's impossible. Void. Oh, these are just the specific ones. Okay, so we need to find print. What a mess this library is. Kind of a shame, because the fix for the library was just still using the serial bit banging. There's IDEs and Notepad++ for Python, depending on how complex of a project it is. Yeah, burn the subs, we just used Notepad++. It was perfectly fine. Remember SciComp Recruiter telling me this module isn't for teaching Python, it's for using Python. That's weird. Wait. Using is teaching. Wait. You must agree with the terms and conditions. Oh my God, this is a lot. This is a lot. This library is pretty extensive. So keywords, methods, there's that. Then there's serial sync, serial async, interface, and parallel. Interface contains just that. And the async is more... Well, let's open it up. Let's just open it all up. Open it all up. I need to figure out what the hell's going on here. Write UNate data. Bool, inverse logic, delay, TX delay, if inverted, while check bussy. Check if it's bussy. Data is equal to whatever if inverted. Oh, they're doing all these inversions in line. Jeez. Turn off interrupts for a clean transmit. Yeah. You'd give math and physics problems and tell us to solve them in Python without teaching us Python. What the? It's a class on how to find the answers. Import physics.h. Import physics. Tuned delay of delay. Turn off interrupts for a clean transmit. Write the start bit. Write each of the 8 bits. Oh my God. Hard reset. Initialize. Lower the reset pin. Delay. Raise the reset pin. Delay. And then check bussy. Turn interrupts back on. sreg. What the fuck? They're turning on and off interrupts. They're doing all this stuff that's gonna interfere with our stuff. Because like if we have a button press, I mean we probably shouldn't have interrupts on anyway. But it's like if we do proper button handling, that should have its own interrupts, and it should. I mean, it would just wait for serial to be done anyway. But it's weird. It's crazy. So what I'm looking for are the functions where it's actually talking to the thing, where it's transmitting serial. Just so that I can get, you know, hey, put this character onto the display. Now I can find that in the data sheet, but I'm trying to find it in this library because we have used this library before. It works. And we were using it with async. But I can't find, I mean, like, yeah, great, the keywords are here. But where's the actual code? And maybe it's, but it was VFD.print, right? Yeah, VFD.print. And would that just be a serial print of characters? So if I try to just print out to the serial interface, then that would look like serial 1 print test. Because that's what they're doing. VFD.print. What did theirs look like again? Hold on. Yeah, VFD.print Noritaki. But if we just set this up, it's not gonna, like, how does it know the character set? How does it know anything like that? I don't know. Let's try. Let's just try it and see if it works. Tools, board, Teensy4, serial, 600 megahertz, optimized fast, blah, 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 blah. We actually should probably put a delay in here. And since we're in setup, we are allowed to use delays. We're going to delay for like 1 second. Just to give the screen a chance to boot up and everything. All right, let's upload that. And as soon as it uploads, we might see something happen on the screen. I don't know. I could always hook up the scope to observe the serial port to make sure that something's communicating there. But oh god, it's got to do the first compiling. Takes a minute. Ah, what happened? No matching functions recall hardware serial.begin. So serial1.begin didn't work. Oh boy. So how do I do that with the Teensy? Teensy 4.0 serial serial 1 Teensy 4.1 Teensy boards have 1 to 8 hardware serial ports, which may be used to connect to serial devices like GPS receivers, XP, ESP, Wi-Fi, blah, 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 blah. The most common issue with serial ports on Teensy is use of code designed for Arduino Uno with serial within the code. On Teensy, serial accesses the USB only, and USB and serial 1 pins 0 and 1 are not shared on Teensy. For hardware serial ports, serial 1, 2, 3, 4, 5, 6, 7, and 8 must be used. All right? I don't know if I can just cut and paste their function. X-bar pins may be used to attach CTS or set RX. One connection to the X-bar, flexible pin routing, so on each port you have X-bar pin. Primary X-bar pins, 1, 2, 3, 5, blah, 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 blah. We're not doing X-bar. X232, shifter, yes, yes, yes. TC35, serial 2 of 8-byte transmit. All serial ports on Teensy boards are interrupt based. 3.6 running faster than 120, we don't care. Serial begin, HW serial begin. But I'm not doing that. We're trying to use the built-in serial too. Serial 1.begin baud. All the standard functions are supported. If begin baud is called after serial data is already incoming, any zero data may be mistaken. Detected first blah 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 9 bits, stop bits, etc. Serial 1 right. That's all I'm looking for. I'm not trying to hardware serial though. I don't know why hardware serial is being called by serial 1.begin. It should be software serial. Or no, hardware serial, yeah. Using library audio. Oh, I'm trying to upload the wrong one. No. I guess I have all this stuff in here. Audio, wire, SPI, SD, and then serial flash. And we don't need any of that, and we don't need this either. Lots of weird stuff left over. Oh, and I don't have a variable in there. That's what that probably was what killed it. I didn't set my serial speed. It's bussy, pin mode, etc., 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 VFD init, and then delay, and then serial print. All right, let's try that. That'll probably work now. Another one of the problems with the functions as they exist, the library and stuff, is that it's using delays, and I can't have it using delays because that'll stop stuff from working. Serial 1 print test. Serial. Serial. Capital S. I don't need chat IDE. I don't need chat IDE. Let me work out the problems. I'll ask if I need it. That's all right. I know it's one of those things where you're like, nah, I have to say something. I'm fighting biology if I try to innately just keep people from giving me all the answers the second I come up with them. You see, you guys have a delay. I don't have a delay. So I come up with that answer the second it shows up for me. I guess you guys can see when it shows up because it comes up there. Okay, that uploaded. And the display says nothing. It's getting nice and toasty though because it's been powered on for a little while. So if I hit the reset button and I wait 1 Mississippi, that should probably, let's put the scope up on the TX pin. What the butt? What is that all about? Oh, I didn't plug in ground. Grund. Why is that just high? Sure, we're plugged in properly. Voltage is set high. If I hit reset, 1 Mississippi, and then blah, blah, blah. Okay. Problem number 2. Reset button. Something happened. You saw that. Wait, why is that at 5 volts? Oh no, it's at 3 volts. Already burned the display. No. No. It's just warm. What the? Why are you so toasty? I guess all the 5 volts that it's been putting out. Yeah, nothing here is hot. It's just relatively hot compared to everything else. There's a little bit of heat in the hardware. So I just blatantly output text, but I don't think I set up any text. So I think there's more to the code. We should see like a little glitch happen here. Here, let me unplug this. What in the... What's going on there? Hit reset. Comes back. 0.0174 amp, huh? What's going on with that little shifty voltage level right there? I see a flashing red LED. What happens on this pin? Reset. Then 1 second. We need an indicator LED. I need to put an LED on this thing. So what we have here is we're just going to do digital right LED pin high. And then we're going to set up fine LED pin. What pin is it? I think, does LED built-in works, doesn't it? So maybe we'll just do LED built-in. Where are we? We're at the bottom of our, this thing. LED built-in. Let's just try that. That way we know we've transmitted once the built-in LED goes high. So we upload that. You know, I could use serial number 1 to print the line so that we would have that too. I could even set it up so that we have serial run, you know, we type into the console and then this thing sends it to the screen. Okay, so now the LED over here, which we can barely see. I don't know why that's so dim, because that's in our setup. So if I unplug this from USB and I hit reset, that'll light up. That'll light up. That'll light up. That'll light up. That'll light. It'll light up. I don't know if LED built-in works. The system does not work. Okay, so instead of that, we're gonna have to add a pin here. So define LED pin, and then that one is equal to, is it blipping on the screen and disappearing before you see it? Yeah, because it's a tiny packet at 115200 baud, so it's just gonna go poof, right by the screen. And that's why having the fast oscilloscope on screen was so nice. It's something that I really wanted to have, because when we're doing this kind of stuff and when we're like reverse engineering stuff, signals can go by at a split second. So it's nice to have it at 60 FPS. 60. Okay, so we are looking at what pin is the built-in LED. TNC4 LED. Adapts automatically. Yeah, LED built in. Currently defined in the TNC example sketch, which has caught a couple of people out, since that one defaults it to pin 11. And then it might be here. Red LED, loading status, dim, ready, bright, writing. That's a different one. Blinking is no USB. Ours is blinking right now, so, but that's the wrong one. I think it's, yeah, here it is, LED on pin 13. Pin 13. Why have my DMs been counting up? Pin 13. Okay, so now we just have our LED that lights up when this thing gets through all of its stuff. Try uploading that. I think the default is off. I'm not sure. I may have to write it to be low initially, like after setting pin mode. Oh, no TNC's boards were found. Haha! Hee haha, ho ho hoo hoo. To the funny farm. All right, let's upload that code. We also have a Rigol 10520E. This is the 914 that I have. I love it. It's a very good scope. It's the best scope I've ever had, and it was kind of affordable-ish. Not really. Not really that affordable. But it wasn't like, you know, company price. It was more affordable hobbyist price. So we know that LED is turning on. Yeah, Rigol's been a really good company. I mean, from coming from Tektronix, the features that this thing have are everything you would expect a modern scope to have. It even has Wi-Fi, although I will be dead and in the ground before I give this thing the Wi-Fi password. So what happens is when I hit reset, there's a little bit of a delay, and then the LED turns on. It's hard to see. And then the LED turns on. Wait a second. What the fuck? Hey. Hey, buddy. Hey. Hey. Excuse you. You're supposed to be turning on. What's going on here? Hey. Digital right. Oh, I'm still doing LED built in. LED pin. There we go. No, the little one that's blinking is indicating that USB is not connected. That's what this one over here is. We're looking at the built-in LED, which is this one all the way over here. I just had the wrong thing. Serial is over USB, which is not plugged in. Does the code hang until you plug in USB? No, it gets through it. That is a weak LED. It's a very weak LED. So if I unplug, and I hit reset, yeah, maybe it does hang. What are we doing here? We're doing stuff. Oh no, that just looks like that on camera. Who needs an LED to show the USB is not connected? If you've been burnt before on a USB power cable, I'll tell you something. Some of us have a very specific trauma, and that is from spending hours trying to do a hello world only to discover that all of our shortcomings were that the cable is power only. And then for me, it gets cut in half and thrown in the garbage. I can't suffer power only cables in this shop. But it happens. And so having an LED on your microcontroller telling you that USB is not connected, that's actually kind of smart. It's actually pretty smart, to be honest. If you've been burnt by that once, you will recognize that that feature is pretty nice. So if it doesn't get USB serial, it hangs the program. If I plug this thing in, yeah, the LED turns on. All right, so how do I make it ignore if serial? I've never had that happen before, by the way. I've never had that happen where it hangs up on serial. So what would we do if it would be like an if serial 1? Why would it do that? I guess serial 1 is special. Damn it. PNC 4.0 serial 1 serial hangs. That's not right. Static mount, L serial 2. Normally it freezes a hard fault. I don't know. So I guess USB just needs to be connected in order for this thing to get through the beginning. That's very annoying because I want to be able to plug in and unplug USB from the interface. But for now, I'll figure it out some other time. So we sent it a test. We said test over serial. and it should be transmitting out of this pin right here. So if I hit reset, we should get a little blip that we can barely recognize on this. That doesn't look like anything happened. Hold on, let's zoom out. I'm going to zoom out on the time constant and have it just rolling by so that we will at least see the signal roll over to the side. Will you test the new RPi 2 with the 2 types of CPU? I got a comment about it earlier. I don't know anything about it. If it's something that you just learned about today, I have been streaming. There goes our serial. So that is happening. That is coming out of TX1. You can see it, just this little tiny blip, boop, 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 boop. There it goes. Because the measurement stuff tries to capture it. Okay, so we're definitely talking to the screen. It's kind of stupid that it freezes without a USB plugged in, though. Let me make a note of that. So make a note of that, and then we're going to move down to looking at what we need to do in order to get this thing to display characters. Like, how would we do that? And maybe I'll have to turn stuff into a function. So VFD dot whatever it is, print and text. What is happening behind the scenes when we run that? Pin register, transmit bit mask. And then when we write, and it was in the code, what did it say again? It was VFD dot, I think it was print. Hold on, I'm just going to look for that. Look for the language reference. Oh, it's not up here. It's what window is it? I've got so many windows open. I'm gonna have to take some time to actually learn some of this stuff. So we have reset and init and VFD.print. It's funny that it uses that same .print. VFD interface is model class, reset init, and then we have a begin function too. So we should probably look for the begin. VFD.begin. There's some stuff that I find hard to understand, like when they use these kinds of class stuff and just this sort of library specific stuff. Like that's where they set up async on the ports. Init tx pin write if pin state is equal to low. Bool inverse logic, tx delay, transmit port register. Transmit port register. Transmit bit mask. Oh my god. Check if busy. Data is equal to something or other data. Register mask and invert mask. Oh my god. This is just a lot of stuff. Huh. The button on TC4 is program, not reset. Oh, so if I do, yeah, you're right. I thought it doubled as a reset. I guess it's just a program button. If I disconnected this and then I bounced power to it. Ow, poke myself. Oh, yeah, you're right, it does come back. Yep, you're correct. You're correct. It's just a programming button. I thought it doubled as a reset button, but it doesn't. It does not. It is just putting it into program mode, so I can get rid of my comments. Because I'm a dumbass. Yeah, because I always thought you could run it without the USB plugged in with the serial on there. It just ignores it. I mean, maybe I need to look at the data sheet. Maybe looking at the library is possibly just distracting me a little bit too much. A lot of what the data sheet says is about how to initialize things, or how to make characters and stuff. But let's just see what the data sheet has to say about booting it up. Oh my god, dogs howling at the door. Oh yeah, well, I started late, so I'm gonna go a little longer. Basic function, asynchronous timing, synchronous serial interface timing. I'm hoping we can get around having to do all these crazy timing things. Display image type, graphic display or character display, display memory, the basic window, user window, display screen mode, scanning, and all screen mode, huh? Character display format, commands, character display. 20H to FFH. Display the character on cursor position. This command affects the current window selected by current window select. X direction, Y direction, operation display. I don't know what any of this stuff means. Oh my god. And like, how are they doing it in a library? I'm gonna have to read up on this library and see how it's doing its job. Those are VFD things. So, they like to use their little raise and lower as digital write high, digital write low. Come on, man. Why do you do things like this? Why? It makes your code the most obnoxious thing to read. Util delay.h and stdef. What is that one? Distribution, blah, 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 blah. What are you? What is this? These are things that like people somehow know about and I just don't. And then I look dumb because I start looking it up and can't find it. It's like standard definitions, I guess. What is it? What is... What is this? These aren't words. What the hell? Come on, man. IDE doesn't compile, single sketch, blah, blah, blah. Reference, include is used to include outside libraries of sketch because part of the large group of standard C libraries. It's a C thing. TensorFlow Lite. It's not, it's writing a library. What does S blah, blah, blah mean? This is going to dox me. One sec. Okay, maybe it won't. Higher standard version of C++ than the Arduino platform supports, or with library, should not have used them without proper guards and checks. What Arduino boards are you using? These are the equivalent header files for the version of C++ that support. You might taking stdef and stint, standard ints and standard definitions, I guess, functions, header files. All right. I'm grasping at straws trying to read how this thing is doing its job. So that's so weird. They define direction, raise and lower, and then check. Check is digital read of whatever pin. You could just put that in your code. You don't need to redefine it as something else. It makes just the weirdest, it's very strange. All right, anyway, we are trying to write just like some basic stuff to this, and we're trying to figure out what is needed in order for us to get there. Because I don't think we can just spray cereal at it and expect it to work properly. Async, we are setting up the serial port. RX delay inhibits and stuff like that. And then transmit bit mask. Digital pin to bit mask out. Set transmit. UNT port is equal to digital pin to port out. What the hell? Digital pin to port. Is that a function that they made? Digital pin to port. Program space, delay basic, U7 serial async.h. I don't know where that function is or where it's coming from, but what a mess. What a mess this code is. Draw image. Unsigned X, unsigned Y. Image map. Image memory area, unsigned long address. So this would be command, area, address, height, offset. What does command do? Where did we get this from? Command. So is there void nor take print line, character C, print C, and CRLF. So print find all. It's going to be a bunch. Constant character times data. Yeah, they're using these commands that I don't understand. All right. How to close that window? Oh, there's a little X right here. There we go. All right, so command 8, command 9, line feed, or take GUI 7000. Aloka, is that maybe where that is? Or AVR program space? Because I don't think there's a definition for what command is. It's being imported from something else. Print and command. US underscore command. So possibly interface.h, which I have open here. That doesn't do it. Interface init right hard reset get mode class. And then standard definition in Arduino. So VFD GU 7000. 7000 interface, Nord EAGU 7000 here. And then, oh my God, we've got all this stuff. This one's using command too. Define, if and def, student, util delay. Enumerate image memory data, flash 1, 2, LED stuff, font format. Man, this is pulling apart a library is not something that I'm good at. You guys haven't said anything, huh? And like, where are these defined? These would be in the C file over here. Yeah, these are just defining these. But then all of these use command. What is command? Where is it coming from? Is it from like Aloka or AVR program space? I wish I knew. Try to compile it with every single one until something breaks by commenting them out. But I would think that it would come specifically from something like Noritake VFD GU7000, which I've opened up. I've got it right here. That's not the right one. Interface. Yeah, I'm kind of going in circles right now. Parallel async keywords and methods. And I don't think it's in the key. The keywords are just, yeah, those are just so the compiler knows what it's doing. I've got every other thing open, right? Yeah, I've got every other thing that I need open. Interface parallel, serial async, etc. Examples we don't really need. I'm wondering, you know, if I can find somebody else is doing it. Try to find it in the file where it's used, probably, like void command. Yeah, it would be, there'd be a void in front of it. I mean, here's that, okay. Command, US command. That's defining the class in the H file. Let's see, what are we doing? Command P data with heights lines, model class. Interface, here's begin. I guess it's setting up the width and the height sizes. Is model class, is generation. Oh god, and then we got all this stuff. Nothing very specific here. Display on, display off, select window, separate screens. There's a lot of stuff here. 7000 IO and interface. I'm gonna have to read up about this. This is not what I expected to have to deal with today. I thought we would get something displayed in the stupid thing. It's in the CPP file. It uses that function quite a bit. The command this, command that. Command times shifted 8, command speed. That's for scrolling. What is that supposed to be doing, though? Void command. Not in here. I feel like it's one of the imports is giving us what command is. I'm not sure. You think? Use 700 command, UNAT data, IO write data. What is that? Wait a minute. I've never seen that before. We can use arrows? What does that do? Oh god, Control C. Go to C++. C++, arrow. It's pointer shit. Oh god. Get out of here. For a pointer of class, yeah, very classy pointer, we use the arrow operator to access members of that class. The fuck does that mean? Using namespace standard, we got IOStream, class minus class, private, NAB, public, void, set data, blah 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 blah. P is pointing at set data 5.6. So we're pointing at what? A dynamic object access. So when you use like new, dot is for static access. So we use like a VFD dot display for static access. When we use the pointer, what is the purpose of that? It's setting something within it. Base operand of arrow has non-pointer type my class. Okay, well that just gets into somebody else's error. I'm just trying to figure out how we use this stuff. So we're setting the data. We set write data. We set write to data, or we run what? That function? Are we running that function from the IO class? IO write data. UNAT. It's a UNAT too. Command. And then command XY has some operations going on. Command XY1? What? A to B is shorthand for, oh, Jesus Christ. A static, in parentheses, for some reason, dot function B. So it's essentially IO write like that. Sort of, but not really. Because we would be doing the reference to. Pointers and references are not my strong suit, and you guys are very brave for helping me through this. IO of double means you invoke the write method on the object pointed to by I/O. Write on the object pointed to I/O. So what is I/O in the grand scheme? Input, output, writing data, and we're calling command of something or other, and we're writing whatever data we have. Jesus Christ. Well, whatever data we've passed in there. So command is I/O write of data. You don't need to understand C syntax to understand this code. Write is a function, and it's passed data. I mean, yeah, that's my understanding of it at the moment. I just don't understand the specifics of what that specific syntax is. Like, I don't understand why you would not just be calling io.write data. And I guess I don't need to know, is the point. Yeah, you guys are correct. Whatever's happening, we are calling write data. That's, what is it, stored in IO? IO can be just the serial that you pass it to. It's about where it's stored in memory. I see. But when I'm calling that, am I looking for write now? So what they've done is they've essentially just rewritten command to be some kind of a UNT thing that'll send it over the serial. That'll send it over IO with all the timing stuff that they put together. I had tuna salad and a burger bun for lunch, so that's starting to hiccup on me. Didn't I get seltzer water? I did not get seltzer water. I got a second cup of coffee. That's going to have to sustain me for the rest of the afternoon. All right, so I need to find out, well, what is it doing when it does write? And I think write was stored in a different area, right? Write data, IO write, that's the one. Write mode select. Write screen mode select. That's a different one. See, that's still using command. You can find it by IO. Oh no. IO. Those are all the IO or generation. It's not going to be in here, is it? It's going to be somewhere else. There's a description of all the commands. You can send to the GU7000 on the Noritake website. Are you looking to implement communicate protocol yourself? Yeah, because this doesn't compile. This library doesn't compile for the Teensy 4.0. And even if it did, it would interrupt my other IO, my other serial streams. Yeah, I've got the data sheet open for the. I'm trying to get it to like display anything at all. So yeah, let's take a look at the web stuff, because yeah, we were looking at the data sheet, but it might be better. I looked at the data sheet and I read like, oh, look at what this is, and it's like, wait, I don't know what the hell I'm looking at. So, and then even on the Noritake website, they want you to use their library, and it's like, I can't do that. Okay, so here's direct code characters, and so okay, character code 20 displays the character, the cursor position. See the footnote table, control code, backspace, horizontal tab, line feed, character turn. All right. Dropped into the scene and find it interesting. No, it's okay. I mean, anybody who knows a little bit about anything can help. I try not to be too mean about that. So streamers can get very mean when they're doing stuff like this. I can get very mean when I do stuff like this, so I try to keep myself in check. Okay, so cursor position default is 0H, 1FH, 24H, XL, X8, X. ADR's low, high. Cursor position, cursor set. 1FH, 24H, X. Oh my God. I got to figure out how to use these. Font display. So there was one that set the font and everything, but shouldn't it also be generic? Specify cancel reverse, horizontal scroll speed, specify right measure. Okay, so we don't need escape sequence. We can direct code, character display. Display the character, the cursor position, see font table. How are they doing the translation into that? Because we are giving it a serial like a serial string, and we're gonna have to turn that instead into something that will display, you know, text and stuff like that manually. It sucks because all the screen design programs are probably relying on there being a library. Initialize display 1BH40H. Dip switch is not reloaded. Download font. Oh my god. So then what am I setting it to? If I set serial output to initialize, and I set it 0x1BH, hold on, let's get over to here. Nope. And then, yeah, that would be in VFD init. So serial 1 dot write 0x 1BH. Like that. Oh, H is just defining hex. That makes more sense to me now. Yeah, there aren't 6 okay, that makes sense. So do I need to send it 4.0 as well? Dip switch is not reloaded. Why are there 2? That doesn't look like a 0. All right, let's upload that and just see if it does anything. Oops, I need to plug in the Arduino. H isn't a valid hex character. Yeah, no. Uploading. I don't think just hitting it with serial data is really gonna... Oh, there it went. There went all the stuff. So technically, if the screen is even receiving it, I'm not totally certain about that. What I'm trying to do is emulate what the library would do, because we did get the display working with the library with a different microcontroller. I mean, push comes to shove, and I don't think I'm going to have to do this. I think just actually learning how to use the screen is going to be my best avenue. But push comes to shove, I could put another microcontroller in this thing to run the screen specifically, and then just communicate with that microcontroller. Like, just tell it, hey, here's some stuff. And then the other microcontroller goes, here's your wonderful display and interface. And I could use this the second micro, sir, a second microcontroller has hit the project. I could use the second microcontroller to do all of the test and measurement stuff. So this one would be sitting separate from everything else, doing all the test and measurement, and then streaming numbers over to the other one so that it can do display and interface kind of stuff. I've seen that done before, but I don't really think we're going to need to. This microcontroller is such a bruiser. Once we get stuff on the screen, I think we'll be in good shape. But I really would like to get something to display on this display. So when it VFD, well, when it starts up, what are the commands that it's issuing? Oops, that's our 3D model of the whole thing. Looks rather like the real thing. Bleh. Yeah, 0x0a, 0x0b. So it is just sending this stuff and making sure that the serial line isn't busy. We haven't implemented that. We'll implement that at some point. So back, forward, line feed home, clear screen. If we set it home, 0x0a, And I may have to put delays in here just to make sure that everything is properly timed, and then we'll have to make it a delay agnostic system, which is always very annoying. Download font we're not going to need. Direct code, character display, 20H to 0FF. Really? All the way up to 0FF, huh? Font table somewhere else. Font magnification, command description, how to create the menu using highlight effect. Oh, that's kind of neat. GTSP user guide, beginner tutorial. The problem is I looked at the beginner tutorials and they pointed me towards the library. That's the quick start guide. Plus it's for a different series. But this is the 7,000 command description, so that's pretty cool. Shouldn't it, do I really need to do vertical and horizontal? I don't think so. Cursor set should go, cursor move to the specified XY position. But if I'm displaying certain characters, I guess I need to look at the font table in order to figure out what characters are what. That little window is very annoying. I really wish it would go away. Select the international variants of ASCII. Set this extended ASCII. Wide range of international fonts. None of this is, I'm looking for basics here. Yeah, I don't want the international variant of ASCII. I just want to display a string, and I need it to come over as the proper ASCII. And I guess it starts as 2AH and goes all the way to, yeah, okay. All right, so Arduino serial LCD display characters. Don't you get involved, AI. That's all I want. Little hello world right there. But I want to manually do it. Oh yeah, it's got all, this one has the SPI. I specified serial too, Google. What's your problem? I've installed some custom characters in my serial LCD. String test 1, string test 2, serial print test 1, arrow test 2. So if I just send it text, if I just define a string in text, it should just send it, right? It should just display it. Create character. Huh. Liquidcrystal.h, of course. I mean, if I can get it to display anything, that would be nice. So I think I can keep this in here. Pop, pop, popsicle, test. Now we'll just do. Hello world. So if I hit it with these serial, it might be ready to display characters. I'm not certain about that. It doesn't seem like it needs any other help doing that. Oh, really? 48, 65, 6C, 6F. Is that, but that's not gonna, if I do ASCII to hex, and then I send it those serial, if I send it this, it'll say hello world. Do I have to do that? Or is it just gonna send that anyway? I don't know, let's upload and try it. Let's just try it, see what happens. Because I think I'm not defaulting the cursor, but I am resetting everything, and I'm initializing it. But I haven't told it that I want to display text. But if it just gets text from serial, will it just put it up on the screen in the default position? I'm slowly learning this. slowly learning it. The Arduino code does a hard reset, then 1B40, and then ASCII characters. And that's what I have, except I'm also hitting it with a 0A. What's up, Sir Hiss? What you're doing should work. Well, it hasn't done anything yet, so that's not looking good. So we possibly have a hardware problem to blame. And that LED is on, and if we reset, unplug, and then reset, boop, boop, that turns on, no. And we saw something go by on the LCD. What I'm doing should work. That's reassuring. Unfortunately, nothing is happening. Let's put some delays in here. Now I'm using delays right now because this is the only thing the microcontroller is doing. I'm going to have to pull them out later. But we're just gonna put some delays in there so that this thing has room to think. Hit upload, right? Yeah, there it goes. Hey, Ben Gizmo. Ben Gizmo, I already asked you this, and maybe it's my memory just not working. You didn't have the M303 repair guide, did you? The PDF file that showed us what components to replace on the M303? Because I've got somebody who wants to send me theirs. We have to work out all the details, but I could potentially just use that guide and fix it immediately and return it. Oh, no teensies were found, right. Hit the little button on it. Did it upload? I'm going to do it again. Okay. Unplug this, bounce power. LED turns on. Oh! 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 I found a single page, but I don't have the whole manual. Yeah, can you send me that single page? I want that single page. I lost it. I may have saved it actually to the downloads folder here. The original write used delay 1 microsecond. I'm gonna have to rewrite those delays though. What's up, Groovy? During hard reset, the Arduino code does some magic with setting registers to input, output, and high and low. Arduino code does some magic setting registers. See, I told it to say hello world. It's a little jittery on camera. It looks smooth as butter on the actual thing, in real life. But yes, something is coming out of there. We got something. If I reset this again, it's probably going to go haywire, right? It looks like it got the reset codes. Oh, but it's not displaying anything now. At is 0x40. Oh, that's that's the bottom of my code. Oh no, yeah, serial 1 write 0x40. After you set the reset high, you need to wait 100 milliseconds. Oh, okay, so try that. It's still compiling. Still compiling, still compiling, still compiling, still compiling, still compiling, and it's compiled, and I think it's uploaded, and of course it's not doing anything. Oh, because I didn't plug in the Arduino. Bonk. And then hit reset. That should upload my code. There go my signals. And nothing. Nothing. It's kind of risky here sending 5 volts into that pin, but we saw serial go by, but it didn't say anything. I think in the chaos that I had before is when stuff actually happened. So what am I not doing? What is the state of the busy pin? Let's check the busy pin when everything is happening on this. So I'm going to go to here, and we're going to hook up Bussy. Try to get everything on camera at once. There we go. So we're going to put the scope on Bussy. This is Bussy. And we'll see what that does when we reset here. Oh, that doesn't reset it, actually. This does when I unplug USB and then reset 5 volts. 5 volts goes back on. Did we see it there just then and I missed it? I think I looked away. I guess there are some events happening. What about the reset pin? Why did it do that? It's doing like a little blah, blah, blah. I wonder what that's about. Let's check it over at the 5 volt line. Oh, that one's not connected. This would be the, what is it? That pin is the busy pin. Plug that in. And it glitches out for like 1 second, but it really doesn't do anything after that. Not sure if there's a difference between ESP32 and what you use. But I need to use serial 1 print line instead of serial 1 print. Print line just puts a return on the end. Maybe we could try it. I mean, I'm also using write and not print. Or no, keep write there and use print line here. Try it. Hey, Madam, you. All right, that should be going in any second now. And then all of a sudden, my display says, oh, it's still compiling. I need to plug this in before it finishes. All right, it's about to upload it any second now. You'll see this LED do some stuff, or not. Nothing. Take that off. Reset. Yoink. Yoink. LED is on, which means that it's finished all the stuff that it does. And we still don't have... We were this close. We're so close to getting it to work. What it did is it displayed this here. We want it to display this here. So what commands am I sending it, and are they working or not? I don't know. And close some of this stuff that's distracting. Get out of here, get out of here. And we are looking at set the international variance of ASCII. No, we're not doing that. We're keeping our fonts normal. So that would be here, command description. What's that? The library drives reset low for 1 millisecond and then drives it high and waits 100. Then sends 1B40. After that, you can send full strings. So 1B40 would be that. So let's try emulating that. And we get rid of this. So digital write S reset low. Delay, we're using delays, we're not supposed to, but 100. And then we write it, and then we wait. And also we fix our spacing. Try it. Beep, boop, beep. Compiling sketch. It takes a while to compile. This is a big microcontroller. There it goes. Uploading. And... damn it. Nothing! Whoa! That was just me jiggling the cable. Alright, reset this. Pull this out. Put it back in. That was it sending the data. I mean, if I bounce power to everybody, let's turn everyone off and on again. Boop. And then boop. Yeah, some weird stuff going on the up on the digital signal that's coming through. But it appears not to be doing anything. Although I did get rid of that extra delay. Wait a minute. Give it a minute to think. There. They're all delay 100s now. Although we're delaying for an entire second, so no, I don't need that actually. These probably don't need delays between them, but we're just doing it. Write a character after 40. Okay, well, I can try. Just put another serial write 40 in there. It'll make an at. There's the teensy, and then this thing does its thing. Loads it up. We got a couple serial signals running by. Still nothing from the display. Still not doing it. Although sending it to 4.0, shouldn't it 2.0 to FF? I'll send it an H, I guess. Well, let's use an H then. 6.8 is H. Serial 1 write 6.8. Reset low, reset high, 1B, 100 milliseconds, and then we send it 4.0, and then we send it 6.8. No, it says it's serial print line hello world should be sending to the display. All right, so it's compiling and uploading. Before you do VFD init, you put a 400 milliseconds delay. That's not, I mean, that's after the serial begin. All right, that still didn't do it. We had writes go by too. You're saying I need a 400 here? Let's try it with that 400 delay before initializing. Suggesting it as it is in the sample code. Yeah, but I just don't think the delay after initializing serial is doing anything. So we should be serial writing a 0x68. That should be what's coming out of the serial port. When I bounce power. Oh, that didn't even turn off. Hold on, turn that off, output off. This thing is still lit. Oh, because I'm plugged into USB. All right, unplug USB. Keep forgetting about that. Turn it on. We get a bunch of serial writes in here that are delayed. H. Hey, there's my H. All right. All right, so I got it to display H. Oh, that was the wrong scene. H. So instead of H, let's hit it with that hello world. When she hits you with that hello world. And see if that does it. I don't know if that'll work, but... Oh, plug it in. These delays are going to be a massive pain in the ass. Yeah, it is writing to the actual serial pins. It's not necessarily specifically writing to the monitor. Oh, no teensy boards. Come on. Give me that code. All right, we saw the serial roll by, but I guess that didn't really work. So I'm going to power us fully off and then fully on again. That's not even working. What the? Oh, output's still off. Oop. Hello, world! All right. It's a little jittery for you guys. It's not as good as I think it probably could be for you. For me, it looks totally clear. It's not flashing like that. So I can serial.print text onto the thing. There are ways to make it do smaller fonts and stuff, but we at least got the initialization out of the way. So how do I handle like delays that don't pause the function of the microcontroller? Because these delays are probably going to represent an interruption in the I2S systems. Now, in terms of like initializing and starting everything up, you know, that's okay. But when we get into the main code, I needed to be able to push stuff to the display without a delay in it, which is annoying because I could probably put another microcontroller on it and use all of the libraries and have this microcontroller simply communicating numbers to the other one. No, this thing is fast enough. We can make this thing, oops, we can make this thing function fine. What just happened? I poked it with my finger and everything stopped. Unplug it and plug it back in. This is concerning, that if I don't unpower everything, this thing isn't putting it into a proper reset state. That's a little concerning. Why is it like that? So it only works when I fully reset. And then my text jumps up on the and then my text shows up on the screen, and then my text shows up on the and then my text. What is going on here? Make sure all my power supply wires are good. Turn it off, wait a couple seconds, turn it back on, and then it sends all that stuff. And my text shows, what the, okay, something weird is going on. Is it me? Am I doing it? No, surely it is not me. We do see the serial signals run around, so. Delays between sends is absolutely fine. Not when I'm streaming I2S audio out of other parts of the microcontroller. And I don't know if the Teensy 4 is doing stuff in the background, if that's going to interrupt my I2S streams. It won't? I don't believe you. Why did that work once and then not afterwards? Strange. Yeah, I got the LED on too. And if I disengage the microcontroller's power, everything's off, turn it back on, this thing comes on, nothing. Delay might not be blocking on a Teensy. Dunno. I don't know. I'll have to test it. Hardware serial controls the send timing, and the audio is handled by interrupts, so delay is fine. All right, we'll see. I'll put it up to the test at some point. Right now, I don't know what's going on with this, because apparently this runs once and then never again. I'm going to throw it up onto the Arduino again. I'm going to throw up... all right, let's upload this. Try again. Upload it again. Over here again. Again. LED is on. Unplug this. Again. Turn this off. Wait a couple seconds. Turn it back on. Serials are sent. The screen once more ignores us. What is happening? Why is this happening? I mean, we're in asynchronous serial mode. Oh, did my 5 volts slip? No, because it's always been drawing full current. There go the serials. Nothing. Why you do this? Why do you do this to me? What have you done? Why have you done this? Of course, this doesn't do anything, but it's fun. I haven't hooked this thing up yet. We may have to use some type of interrupt logic in order to get the twistings of this. We should be working on that right now, but we're not. We're trying to claw our way into a functional screen. Nothing has changed. So what in the world happened to my serial sends? This is an encoder. We're not doing synchronous, we're doing async. Copy the right function that's in the file serial sync. Well, let's see what's in the serial sync. Wild Bussy. Lower SCK, delay microsecond. If data and I raise out, else lower out. Raise serial clock, delay. This is raising and lowering. This is bit banging the responses with a 1 microsecond delay. Man, why does it do this way? Yeah, serial async I have right here. UN 8, I is equal to 8, I minus minus, send a 1 or a 0, tune delay of delay, and then it turns all the interrupts back on. So it turns off interrupts, goes through all this stuff, and then turns them back on, which is why this won't work with. So, I mean, they have a microsecond delay manually coded in, even though we were able to get this to print at one point. Yeah, that's what the library does. It turns off interrupts for the duration of the serial write. Where's my link to the PDF? To that repair PDF? Or do I need to start Googling for it? I'll work on that in a bit. Yeah, I don't know. We're close to my normal closing time. I started a little bit late today, but we got something to happen, but it's like totally unrepeatable. I don't understand what happened there. Did a wire need to be jiggled or something like that? I mean, we saw the data going all the way to the display, right? So if I jump in right here on the serial line and I reset everybody by powering it off fully and then powering it all the way back on, we see Nothing. Huh? Those three connected. This one connected to 3 volts. Is like my microcontroller damaged? What does the 3-volt line look like? Looks a whole hell of a lot like 3 volts. There's A1. And that comes out here in 5-volt flavor. And if I turn everybody off, turn them back on, we don't see any serial activity. What the butt? Why are you not working? Why must you do this to me? The display and VA is all plugged into 5 volts. We got 5 volts coming out of there. The only thing we don't see is activity from there, and yet our microcontroller is still writing as a good little microcontroller. It's still doing its job. This is definitively connected to A1. VA is going in there, unless the chip shit the bed, which I don't suspect it did. If I bounce this, it should have a result on the output line. No, maybe not. The status of the OC pin. If OC is pulled down, then you get 3 states out of this thing, and this is not 3 state. So ground is on ground, positive is on positive, our display is powered up properly. The micro, if I pull it up and then put it back down, it's going to go through the sequence again, and it might just be a very quick little blip over here, but it should do something. It does nothing. Okay, so our level shifter might be at fault here. Why would it have borked suddenly? Because we definitely see the serial lines do stuff here. We're on 3 volts, and I reset everybody. We see the serial go by. So it's not like our scope is set up badly. It's that this, for some reason, is ignoring the signals. This can handle 115200 baud. Surely. Where's our data sheet for that one? Oh, I'm going to get back to that. Well, not yet. This is the LT. It's $7 a chip. Can you believe it? Stupid expensive for something like that. Yeah, it's just, would that pin, maybe that pin is floating badly. What was the part number on that thing? The OE pin I'm wondering about. If, like, that activity, like, instigated it to go into a certain mode. YF08E. YF08E data sheet. Bidirectional level shifting blah blah blah. Oh yeah, it can definitely handle those speeds. When the output enable pin is low, all outputs are placed in high Z state. To put the device in the high Z state during power up or power down, when the output enable is low, all outputs are high Z. Do I need to run this to a high voltage level? A to B, A-B port time. That's all timing stuff. It's very specific. In, out, VCCI, VCCO, pulse duration tests. That's where OE goes to one-shot accelerator with a gate bias. What do I do with the OE? Hold on. Ground there. OE is set to low. I don't think I burnt it with 5 volts. That would be crazy. Let's set OE to high to get this thing to communicate, and maybe we just got lucky. Keep OE low until VCCA and VCCB are powered up. So maybe I do need to set that to high. What voltage level is it going to? Is it going to be need to be at 3 volts? Probably. All right, so let's set OE to 3 volts. I'll just get a. Let me just get a sloppy jumper. Oh, that sounds like a horrible thing. A sloppy jumper. Ugh. Here's 3 volts into OE. Like that. And then I hit reset on everybody. Turn them off. Turn them on. Oops. Turn them on. Ah, there we go. This happened to be floating in a state that enabled it. And now it should be pretty consistent with it. Yeah. There we go. Okay, so we solved that one. OE, they didn't show connected. They showed it connected in weird ways, and it didn't click with me that it was an output enable. But yeah, see, they show it like this with like a microcontroller. It's like, why do I care? Yeah, it was one of those floating pin things. Ship it before it stops working. Ship it, turn off the stream, close it down, don't let anybody see. The flickering of the display is interesting to me because I thought that it would keep those elements powered instead of having troubles at 60 FPS. I'm a little bit annoyed that it is like that. Because like I would love to have you guys be able to see what's going on the display while I'm using it. I don't know if there's going to be a way for me to get the frame rate of the screen to be a little bit more compatible with the cameras. It looks brilliant from my view. Yeah, it's the frame rate of the camera not syncing up to the refresh rate of the screen. And there's no word on like what refresh rates are on this device. So hell yeah, hello world. Yeah, we did it. We had a floating pin issue where the display wasn't getting serial, or it would get it intermittently. Save it, you have something unique. Yeah, it's so hard for you guys to see. I don't like that. And sometimes if it gets a little dynamic, like if I cover it over with stuff, see, there you go. Then it comes back and it suddenly syncs up. I don't know what in the world is doing that, but what is doing that? It's so weird. It's the yeah, it's the white balance. White balance appears to stabilize the VFD. So I move my thumb over here and the white balance changes. So if I actually do rack view mode, oh, my eyes. Perfectly stable. It's the white balance. It's white balance doing stuff to the camera. Less balance means that as the characters fade out, they fade out faster for the camera. So while things are not that bright in here, that's the happy place for it. Well, okay, so we got Hello World going. Pretty cool. Given the speed at which I see this thing flickering, I don't think there's going to be any problem with it displaying like an oscilloscope. But we'll have to get to the bottom of that. And then the code is rife with delay stuff in order to get the serial to come out properly. And I want to work around that and see if I can get away with not having certain delays and stuff like that in order to get the screen up and running and pooping away. But the next thing that I'm going to work on, now that we've gotten the screen to kind of work, I'm going to keep that set up and work with the power supplies and try to get those done. I want to get the current monitor and voltage monitor done on my own. I'm going to work on that. I'm going to do 2 resistors and then tweak them around until the 2 lines match up. And hopefully I can get them to match up properly. And then I can have my 3 displays ready to produce all of the different display stuff that I want on the front. I can start building up the power supply. When I get the power supply built up, that means that we'll have this as kind of like a platform that we can start building up on. It's going to be basically layers of circuit boards behind there where I can kind of spread out and make the circuit big. And eventually, we need to start designing all the UI elements of this thing. The LEDs are going to be powered on whatever comes in or out of the pin. It's not going to be digitally controlled. The buttons are going to be digitally controlled, and I have to think about how they're going to interact with either menus or different, I don't know. I don't know how this is going to work. The delays won't hurt the audio. If I have all those delays and I'm going to try to scan to see if somebody twisted the knob and I can't use interrupts, it's a whole thing. It's a whole cascade of shit that I have to deal with. It would almost make sense to have a separate processor doing the screen displays, even though this thing is a fucking beast. This thing is an absolute beast. All right, so we got a lot of work to do. We got a lot of building up to do. I know what the hardware should look like now, and I know that we can run the serial stuff along with. Yeah, it's a big shit cascade and a shit storm. Oh my god, I'm glad we got that working today and know what the problems are. I don't like the delays. I don't like them, and that may just be me. That might be on me. But yeah, the yak. We appear to be running out of hair on the yaks. We may. It seems as though we're going to start, we've made the turn, right? That part where you're working on a car, when you turn all of your wrenches from loosen to tighten, that point, we always sync that up. We're, guys, let's go. It's loosen to tighten time. Click. And then everything starts to go back together. Right now, all our shit's out on the driveway, and we're just starting to sort of piece things back up and together. And so eventually we will get the car running. And eventually we'll go on the road trip. But right now, everything is all over the place. We are just at the turning point where what I've vetted out is possible. We've decided on how this thing is going to function. I'm not going to do two processors, even though that would be a lot cleaner. You'd have one purely do the interface and stuff, and then you would have another one doing all your test and measurement. It's a little crazy, but it is something that you can work out. I don't think we need to do that, because our microcontroller is going to go through its whole program in a split, like, fraction of a second, because it's running at 600 megahertz. So we're going to be, our loop time is going to be like nasty. And I think we can get around using interrupts because our loop time is going to be so nasty. The question is, can we use the bounce library with everything else? There's a lot of questions to answer. There's a lot of hardware to build. So perhaps next stream we start building up the hardware. Maybe we get all the hardware built up and we start coding it. Now that we know that it can kind of coexist. Oh, see the bad boy to 1 gigahertz. I know you could do it, but I don't know what's involved in that. It'd be crazy. I ran audio in an SD1309 on my TNC and used encoders. It's totally fine. Yeah, I'm thinking that our loop time is going to be so nasty that we will catch the high that comes off of the encoder, like, no matter what. And we'll just have to be wary of whether or not some of these libraries are using interrupts or not. Getting an interface on this thing is going to be absolutely a nightmare. And maybe I'll use LVGL. LVGL is a screen design library. I kind of need something a little bit more monochromatic, but I don't know. We'll have to see. We'll have to see what we can do there. Okay, that's it for me. I can't do this anymore. I can't do it anymore. The viewer numbers have been going up, but we had Alro Leo sub for 3 months. I think I missed that. I missed Alro Leo. Sorry if I did. You guys can just tell me I missed you because there's like 3 of you here. Celia Russell gifted a sub to Leb TV Live a day ago. Oh, Alro Leo was yesterday. Nobody has subbed today. That or my Streamlabs isn't caught up. Hold on, let me refresh Streamlabs. Let's make sure. I'll make sure I'm deeply unpopular. Yeah, nobody has subbed. I would like raid you guys into Milton, but I don't know about the whole science and technology raiding into like gaming streams. Milton T. Pike 1 is back. He took a 20-month break to have a baby. He had a baby. So he's back and he's having a whole... Oh no, never mind. He ended by now. It's cool to see him back to streaming though. It's going to be a wild ride. Other than that, we got work to do. I'm going to be doing my work over the weekend. Hopefully I can give you guys big updates on stuff that I've built on Tuesday, which is when I'm going to be back. I didn't set up any of the commands. I forgot to go into Discord and do that. Let me do that real quick, and then you guys can figure out where you want to go from there. So I go to admin, and I go and I highlight this thing, and then my next stream is going to be on, what day is Tuesday? It is the next month, so it is 10/3. Oh, and I can just say SEP. Sorry, 9/3. No. 10/3. 10/3, September 3rd, 2024, 12:45, Toronto time, because Octaj set up these commands and used Toronto. SEP SEP02. On the 9th, I have a bloodletting appointment. I don't know if that collides with anything. On the 6th, 7th, that's a Monday. Okay, we'll be fine. We'll be fine. I'll get my blood drawn in private. And then they throw it out. They throw it in the garbage. They draw a bag of blood and they go, see this? I'm like, that's my blood. And they're like, yeah, it's fucking garbage. And then they throw it out. Yeah, it's bloodletting. I have high iron in my blood. I have a lot of iron in my blood. So the only way that they can get rid of it is literally by bleeding you out. Okay, so thanks for the stream. Hope it goes well. It will, and thank you for the help. I'm a little frustrating to work with because I'm a little stubborn. Here's the end card. That should have all the right information. 3 days, 18 hours, 59 minutes, and 52 seconds. I will be back, and we will continue our work, our dark work on this module tester module. At the very least, by the time I get all the hardware together, we can have just a rudimentary measurement program running on the thing. I don't know about menu systems and all that. I may have to find like a plugin to do it, but we'll figure it out. In the meantime, stay away from lead. Don't listen to my chat. They don't know what they're talking about, and they think that lead is perfectly safe. It's not.